new advance in technology changes the layout of the battlefield. No one knows this better than the serving and veterans who are present today, who have seen many a battle in their lives. The first industrial revolution, which began in Scotland and bordering England, it came with invention of steam engine. That changed the logistics of warfare. Instead of relying on horsepower or bullock-driven carriages, suddenly you had steam engine pulling the train, carrying both men and material. Second industrial revolution followed. It came with internal combustion engine. Suddenly you had petrol and diesel fired engines, and that made it possible for us to have many modern platforms being inducted in Army, Navy, and ultimately Air Force. Third industrial revolution was digital. First two revolutions India missed. They happened when India was a colony. But the third industrial revolution was digital, and that is where India participated as a free nation. We take pride in having been on the forefront of IT revolution in the world. This revolution came with semiconductors, computers, and the internet. Information technology became that was to become the main currency of the warfare. Now we are on the cusp of the fourth industrial revolution, the era of digital hyperconnectivity, the industry 4.0. Sometimes people in a lighter vein say that now is the time when robots will talk to one another. They were waiting for the language and connectivity. Now in Industry 4.0, platforms are augmented with wireless connectivity and sensors connected to a system that can visualize the entire battle landscape and many a time make decisions on its own autonomously. As we move away from conventional warfare, we can see that warfare is increasingly becoming a function of connectivity and is not limited only to firepower. For military and commercial organizations both in the defense sector, this means getting ahead of the digital curve and putting in place solutions that can act as a strategic enabler to manage the shift. Today, even a group of soldiers can no longer independently sift all the data and signals which they receive from the noise which is in the environment and generate actionable inputs for combat action, given the volume, variety, and the velocity of data. This presents several challenges, which range from data collection, assimilation, and analysis to all of which what I mentioned requires software and appropriate hardware to support that software, the data banks, applications, and data servers. The arms race of near future revolves around data analysis and artificial intelligence to convert data into real information and gain an edge over the adversary. In the coming days, robotics, automation, and miniaturization, they would offer viable means of gaining information, conducting surveillance, and delivering ordnance. In the era of digital transformation of defense, it takes an immense amount of capital and investment to simply keep pace with fast-changing technological landscape. The adoption of technologies such as big data analytics, AI-powered decision support systems, and the automation of various systems are on the verge of radically altering the requirements of the defense services. No country and no military can afford to be left behind in this revolution. This e-Symposium has gathered the best available talent, and it will be enriching for all participants to identify new skills, opportunities for startups, and aiming for Atmanirbhar Bharat. India, after all, is an IT power hub. We ourselves and our group have India's among the largest IT companies, and we are working steadfastly to improve the world with artificial intelligence. I am certain all of us present here will contribute to India's growth. I do wish everyone present here the very best, and I'm sure today's symposium will bring out a clear path forward. Jai Hind. Now, I may invite Admiral Dhawan to kindly deliver the theme. Admiral.
Thank you very much, Mr. Shukla. Air Chief Marshal Bhaduria, the Chief of the Air Staff, Mr. S.P. Shukla, the Chairman of FICCI's Defense and Aerospace Committee, Mr. Dilip Shenoy, the Secretary General FICCI, Lieutenant General David Dettula, the Dean of Michel Institute of Aerospace Studies, USA, Professor Julia Sutcliffe, the Chief Technology Officer, British Aerospace System, UK, Mr. Vivek Mittal, the CEO of Vegamex Technologies, Mr. Sudhakar Gandhi, the co-chairman of FICCI's Defense and Aerospace Committee, our eminent members of FICCI and SAMDAYS, our esteemed mentors, corporate members of SAMDAYS, Zen Technologies Limited and Anand Technologies Limited, the distinguished participants from across the world, ladies and gentlemen. It is indeed a distinct honor for me to accord a very warm welcome to Air Chief Marshal Bhaduria, the Chief of the Air Staff, for this e-Symposium on Artificial Intelligence for Air Warriors, where our aim is to empower the air warriors to fight and win the wars of the future by leveraging on artificial intelligence. At the very outset, I would like to thank Mr. Dilip Shenoy, the Secretary General FICCI, for organizing a series of webinars in collaboration with the Society for Aerospace, Maritime and Defense Studies as the knowledge partner. In the past, these webinars have been on the subject of negotiating defense contracts, the defense exports, leveraging leasing, and today's e-Symposium on artificial intelligence. One of the objectives of SAMDAYS is to assist in innovation in emerging advanced technologies such as artificial intelligence, to promote the technological superiority in our armed forces, and this is to be achieved by vibrant participation between the public and the private sector. This is where the corporate members of SAMDAYS, Zen Technologies and Anand Technologies are playing a significant role in assisting SAMDAYS to achieve its objectives. Our objective is also to promote Atmanirbharta and Swadeshikaran, self-reliance and indigenization in the defense sector. It will be our endeavor today to examine how we can leverage artificial intelligence in various operations of the Air Force, which could be related to combat air operations, the autonomous airspace management, the combat search and rescue missions, or sensor-to-shooter integration. As you're all aware, artificial intelligence has become a critical component of modern warfare, and military systems which are equipped with artificial intelligence have the capability to handle large quantum of data in a super efficient manner. Artificial intelligence therefore directly impacts on air power and also helps in promoting exponential capacity, capability, and competence among air warriors, along with a host of deep-dived intelligent inputs which were not available to the air warrior till a few years ago. Such systems help to close the kill chain and to complete the OODA loop well ahead of the adversary, thereby providing a distinct advantage to the air warrior in sensor-to-shooter integration. During the course of this e-Symposium, We will discuss these smart strategies and also listen to the views of experts from across the world. And these are drawn from different specializations from the Air Force, from the global industry, as well as the scientific community. And they will all tell us how we can leverage artificial intelligence and technologies to shape the future of air power. The technical sessions, coordinated by Sam Days, here our expert panelists will actually examine integration of artificial intelligence technologies into different aspects of air operations. While examining the manned and unmanned teaming, the discussions would actually revolve around as to how artificial intelligence enabled applications coupled with human machine interface can support galloping trends in effectiveness of air power. The integrated initiatives which will follow will actually throw up a few options. Some would be the artificial intelligence enabled systems, which are autonomous in nature and enjoy total autonomous liberty, while others would be artificial intelligence systems with humans in the loop. Another area where artificial intelligence is gaining prominence and emerging as a force multiplier is the target recognition and the targeting capabilities. Here, artificial intelligence enabled systems would assist in the target selection as well as engagement, and these systems would definitely be more rapid, accurate, and precise and have a role to play in future combat operations. In the past few years, we have seen increasing trends to utilize artificial intelligence in the fields of logistics, of military hardware, as well as in predictive maintenance, cyber warfare, asset management, human resource management, and other activities which are not only time consuming, but also take up a lot of human resources. By optimal utilization of artificial intelligence, we can achieve greater automation and actually free up a lot of valuable resources so that the Air Force can concentrate on its primary tasks, which would be in the region of air dominance, strike, air mobility, intelligence, surveillance, as well as reconnaissance missions. Today, we would have the opportunity to listen to experts from across the world. And here I would like to indeed welcome all the participants across various time zones. We are indeed thankful to you that you have netted in on the Easter Monday, which I know is a holiday in your part, but we are very thankful that you are here with us. And I'm sure that the enriching presentations as well as the vibrant discussions which follow, will throw up some path-breaking suggestions as to how the air warriors can be empowered to fight and win wars of the future by leveraging on artificial intelligence. Thank you very much, and Jai Hind.
So you're muted, Mr. Shukla. You're muted, sir.
Yes, thank you, Admiral Dhawan. You have really set the tone for the rest of the symposium. Thank you so much. Now, Vivek, we will present the green certificates to the dignitaries. Can you please put them on the, yeah. So it is our privilege to present the green certificate, which means we are planting 6 trees, which is the tradition of FICCI. And in a virtual world, in fact, our tradition of planting trees has come in very handy. Bhadraya Sahab, kindly accept this small token of our appreciation that in your name 6 trees will be planted. Thank you, sir. Next certificate, please. We are also planting trees, FICCI tradition, Secretarial Development. Sir will know that in India, there will be 6 trees planted in West Bengal, India, in the Sundarbans, Royal Bengal tiger. That's the land of Royal Bengal tiger. So I'm sure there will be a little bit of India you will remember through this. Thank you. With that, it is my privilege and honor to invite Air Chief Marshal R.K.S. Bhadoria to kindly address the symposium. Sir, over to you.
Chairman Samdes, Admiral Dhawan, Mr. Shukla, Head of Defense and Aerospace, FICCI, distinguished dignitaries from defense, industry, academia, ladies and gentlemen, very good afternoon to you all. It's indeed a privilege for me to share this space with eminent personalities from across the world. I would start by complimenting the society for choosing the most relevant theme here today, a technology that is poised to change the nature of warfare in the years to come. The theme AI for Air Warriors encompasses the concepts of technology, the area of application, and the imminent need to do it. Traditionally, air forces have been the lead consumers of all the advanced technologies before they get proliferated to other areas. However, in the last few years, we have seen evolution of many new technologies in the non-military domain, which eventually got adopted by the fighting forces. AI being one of them has seen exponential growth and applicability in the commercial sector. And having realized its great potential, now militaries all over the world are racing to embrace it. In the aerospace domain today, AI can bring enormous changes in the way air wars are fought. While currently it has not matured to an extent where completely autonomous missions could be executed, there are multiple applications wherein AI is being used or can be indeed used more extensively for optimizing air operations and compressing the OODA loop at the starting process in efficiency. While AI is being developed in multiple areas in the air domain to accrue diverse and asymmetrical operational benefits, the questions which we need to address in the process are some of them I'll just point out. Whether algorithms can be trained to effectively exhibit intelligent mission planning behaviors in unpredictable battle scenarios. It's a starting question that we need to address and start thinking on. Can machines be taught combat strategies? Of course, yes. And how does it become applicable to the air power and to what extent? Could sufficiently generalized representations be built to capture the richness of the planning problem itself across the threat matrix? The answer to these questions will help us firm up our AI requirement specifications, which will essentially be a starting kind of document vis-a-vis the expected outcomes. If we intend to utilize AI heavily in combat aviation, we may need to redefine or even abandon some traditional principles. These principles are not strict checklists or templates. Essentially, different nations with different threat perceptions would have different requirements, and this would have evolved over a period of time and experience. Assuming that the information fed to it is correct, AI can give you models with impeccable logic to prove that the proposed solutions are the best. But no user, even the AI's own programmer himself or herself, would possess the mental focus, sheer stamina, or math skills to double check hundreds of pages of complex equations and huge proof trees. So this is going to cause some amount of trust deficit for the commanders and the military operators during war. This amplifies as the situation becomes more dynamic and for real-time decisions, which is usually the case in air war. Do we reject an AI solution if we cannot understand it? In doing so, we would be ruling out a host of potential strategies, which may be out of box, but which can give a huge required edge. The risk is that we may get outmaneuvered by an adversary who trusts AI and its offbeat workable outputs. And we must be mindful of this as combat commanders, as technologists, as we evolve ourselves to handle AI in future. To optimally use AI, we must first decide as to when the systems should be supervised by humans and when not. This is a decision that should involve technical logic and questioning. Humans are designed to be more effective at problem solving, whereas AI thrives in environments with high correlations and underlying patterns. Probably the most important consideration in this domain are the ethical ones. Can we ever get to a stage where we clear AI to take a human life? Taking it one step lower in terms of air war, would you implicitly trust a purely AI-based identification of foe? Suppose you haven't got an IFF response. Even if the human is taking a decision to shoot, I leave that for you to consider, and I have no doubt that these are the issues which will form topics of discussion during the symposium. To share with you regarding IF, we have already embarked on the AI journey, and having gone through some very important automation projects in the recent past, we have started testing AI and AI-based applications on some projects which are at different stages. We have already improved our operational efficacy by shrinking timelines in entire Elint-Sigint analysis chain, and thereby leading up to PFM generation for the required scenario in the area of operations. Image interpretation enmeshed with Elint data is already being worked upon, and these are the areas that I'm considering, what areas that the Air Force is already working. In the area of aircraft maintenance, which we have substantially digitized, we have all our fleets onto electronic maintenance management systems. Also, similarly, our entire inventory management has become computerized and digitized. So we have already started to work on a AI-based formulation as to come out with predictive maintenance or predictive threat scenarios or red flags. And this is again a project of importance. And all this that I'm talking about has been done in-house with the private industry. And none of them is kind of a project from foreign OEMs, mainly because of the sensitivity of some of these projects. We are already working on effective training strategies where data recorders, for examples, are being used to identify outliers in a pilot's performance, be it in operations, exercises, using AI techniques to determine the strong and weak points in terms of maneuvering or overall orientation, airmanship, etc. Another major area is to have an automated threat analysis based and AI and decision models for fighter controllers on our controlling nodes, which is in the process of being developed. Again, this improves the situational awareness and assists in decision making as a tool for the fighter controllers. We will also have AI-assisted next-gen technologies employed for threat monitoring in our captive networks and our network upgrades, which are ongoing. This enables software-defined networking, aids intrusion detection, prevention, customizes tweaking of firewall on the run, and routes and aids traffic engineering solutions which were not possible earlier. For the future, and before I go to the future, if I've given you an impression that we have done some great job in AI enabled in the Air Force, I think we have just scratched the surface. And the potency of this technology is so high that we probably are already late. And for the industry, my main message is that it is time that we start really proactively in this field. And for the future, the areas of immediate priority for the Air Force, it is both in the operational training methodology and operational capability enhancement. Domains of manned-unmanned teaming, a concept that we are already talking and quite advanced in planning, weapon target pairing, target prioritization logics, battlefield awareness systems, blue and red force tracking, swarming applications, data fusion, intelligence fusion, and a robust decision support system These are huge areas of focus for our immediate future and is an area that the industry can look into straight away. In the area of training, possibilities are equally exciting and again of very important immediate solutions. To simulate the real world at low cost and train the pilot against exponential combinations of cockpits and combat scenarios. So what the AI can be used to train, no other system can be used to generate the kind of possibilities. We need to generate essentially the deep blue equivalent to make our pilots and combat crew practice all kinds of engagements, thereby ensuring that the actual engagements emerge simpler than the training itself. And we should remain on top always. I would conclude by saying that smart technologies like AI have the potential to totally change the way we train and fight future wars. We are living through some interesting times. It is the right time for us, all of us, the military operators, the industry, the think tanks, and all the AI specialists, for creating next-gen AI enablers for the air war. And if I can take a leaf out of the green tree and the presentation made, I think it is time to plant a robust tree for AI development in the country. On this note, my special thanks to FICCI and Samdas for inviting me. And I'm sure that you'll have a fruitful brainstorming session with the great presentations and discussions. And I wish the symposium a great success. Thank you and Jai Hind.
Thank you, Chief Marshal. You posed some thought-provoking questions. Role of humans, role of artificial intelligence, and invoking trust so that we know that what machine is telling us, what artificial intelligence is telling us. Something like must have happened when autopilots first came. How much can you trust the pilot? Can you leave the plane in charge of the autopilot? Thank you so much for provoking thought. And also thank you for sharing a keen interest, already engagements which are going on. That inspires us all to work harder to come up to date in this field and not stay behind. As you rightly said, we are already perhaps a little late. So we will try to catch up soon. Thank you, sir, once again. With that, I'm going to request our expert, Mr. Vivek Pittal, CEO of Wavecomex. His presentation is on the screen. So Vivek, without further ado, may I request you to go ahead with presentation. We are a little running behind time, so requesting you to kindly start.
Right, of course. So good morning from New York, and thanks for the invite. Let me share the presentation right away. Can everybody see the document?
Yes.
Okay.
Yes.
So, right. So good. So again, good morning from New York. Air Chief Marshal R.P.S. Bhaduria, Admiral R.K. Dhawan, General David Abchula, Dr. Julia Sutcliffe, Mr. Shukla, and Mr. Sudhakar Gande, serving and former air officers, general and flag officers, senior leaderships of the civil services, and members of the diplomatic corps, the academic community, and friends from the global and Indian media, ladies and gentlemen. It's an enormous pleasure and a singular honor to be invited and to be amongst this very eminent and distinguished gathering to talk about mission philosophies for the next generation air warrior. So I'd like to talk about the high-level global trends that are amidst us and that have already been discussed earlier. In terms of the revolutions, multiple revolutions that are underway in the field of agriculture, energy, and military application and military ops, and discuss the common features and fundamental drivers that span them. For example, in the defense segment, maritime, land, air, and space operations are rapidly moving in the multi-domain segment, wherein integrated battlefield management systems, networked with sensors and shooters, aim to optimize the kill chain through the use of satellite imagery, weather information, artificial intelligence, edge computing, networking, and big data analysis. RMA 1.0 dealt with a common picture and shared awareness in a joint combined environment. Meanwhile, RMA 2.0 can be said to describe as acting upon insights from all the various different data sources. Likewise, moving to the world of precision agriculture, it deals with optimization of land, water, financial services, and logistics for optimizing food production. This is a hot topic in India, as we all know. And these aspects are highly critically dependent on the usage, again, of satellite imagery, weather data, real-time information, artificial intelligence solutions, edge computing, and being able to handle massive amounts of big data. Moving to the energy transformation that is amidst us, wherein the entire human race seems to be transitioning from the world of fossil fuels to renewables. We are witnessing the peaking of oil demand, along with negative environmental footprint of fossil fuels, and this huge pressure and compliance with the Paris Accord. It again requires real-time monitoring and reporting of information. Massive assets, pipelines, infrastructures strewn over continental-sized domains, exploration, they require extensive operations and maintenance. And again, the common theme amongst all these different verticals is, again, extensive use of satellite imaging, artificial intelligence, machine learning, and big data infrastructure. So who's VegaMex and what do we do? We provide we're an AI-enabled new space startup, and we provide state-of-the-art data experience using AI for addressing national security solutions, food security, and energy security. Our aim is to provide a state-of-the-art data experience by fielding a unified AI-enabled multi-sensor data fusion engine, which is operating across multiple verticals on a global basis. For example, some of the existing gaps within the military domain appear to be the following. The military lags behind the commercial sector in developing what some people call the infrastructure to take advantage of massive sensor data, including shortfalls in data storage, and the AI computational power. Second, it lacks the necessary and sufficient theories on large data, AI learning, and prediction models. These scalable models, once in the production mode, will allow strategic, operational, and tactical effects with a better understanding of the operational environment, allowing decision makers and war fighters to better orient themselves to the current and predicted situations and enable decisive action. The central objective of the military data collection is to identify and locate specific targets and entities across the battle space with a well-defined end state. ISR, therefore, enables utilization of multiple assets from multiple geographic commands, collecting data across all domains that may satisfy strategic, operational, and tactical requirements. So this slide basically peppers and goes over some sample inputs. For example, space-based sensors for deep targeting and warfighting on the ground in real time. Satellite-based surveillance for dead zones, including dynamic and hidden objects. Robust ground target detection using synthetic aperture radar and IR sensor fusion. Again, ATR, or automatic target recognition, which was mentioned earlier, algorithms and false arm mitigation algorithms. Massive sensor and data fusion of human, comment, OPSINT, SIGINT, and furthermore, integration with C4 ISR systems into an overall combat management system. These will lead to an outcome which will facilitate the multi-domain operations and close the OODA loop faster. Vega can feed data and physics-driven solutions for predictive maintenance, another very important and crucial subject for the Air Force, which will therefore help with enhancing operational readiness. Some of the benefits are the following. It would reduce unscheduled maintenance, streamline the operations, enhance the engineering effectiveness, furthermore, optimize the supply chain, reduce the lifecycle costs, and improve asset generation and fleet awareness. This requires designing, developing, and deploying fairly complex AI and machine learning systems. And I'd like to just mention that a hybrid edge and cloud platform can orchestrate deployment across thousands of edge locations and cloud machines, handle vast amounts of data sets with minimal data movement and processing latency, and allow and enable agile development and rapid prototyping of new systems. This will help with ease of maintenance and upgradation of legacy systems. Furthermore, next generation air operations requires a dispersed and resilient strategy for survival of offensive elements, destruction of layered defenses through disruption of communication and networks and disabling enemy ISR. Mind you, with availability of a plethora of weapon systems like the HQ-9 and S-300 with ease of access, air defense bubbles are sprouting across the globe. This is the future of air warfare operations and command of skies in the coming decades, and these can be overcome with maximum utilization of multi-domain technology fusion. I'd like to briefly mention the data processing and analytical capabilities. The military no longer relies on complex data from an individual sensor. Rather, the large sensor networks complete the picture of the battlefield. Second, AI should be able to refine the network results and contribute to overall intelligence gathering, since it's vastly superior at optimizing the extremely large networks. We are all acutely aware that in-theater data processing generates massive amounts of simultaneous requests, which need concurrent near real-time responses. Through horizontal and vertical scalable architecture, an unlimited number of requests can be supported by modern architectures, systems architecture, and solutions. The next slide, gives you a very high-level overview of the analytical architecture, that will be enforced. So you'll have data streaming in from satellites, from weather, from surface, from UAVs of all kinds, and we'll basically build out a fusion intelligence platform which will consume data from these different sources, amalgamate them, and generate actionable intelligence for the various stakeholders. This is true for the civilian sector, for the agriculture sector, for the supply chain, from the farmer to the bank, to the fertilizer company, to a trucking and logistics, which is in principle equally applicable to a defense organization as well. And then strategically, one can use these algorithms that are field tested extensively so in the civil sector, for the defense and the military applications. For a good example would be these ride-hailing cabs where they match the driver, to the passenger. And likewise, they could be, customized and used for military application, wherein you're optimizing and linking sensors to shooters. A very everyday application being used with such devastating effectiveness for a defense organization. Finally, I would like to make a recommendation that we could be a suitable partner for the Make in India campaign. The approach is to identify and aggregate existing solutions and tweak them for military requirements, crossbreed these technologies and leverage the solved problems for military applications, generate the civil military technology fusion that's been pioneered by China and also extensive, application in the United States. Our office, for example, would extend from space-based ISR to predictive maintenance, to operational logistics, to decision support systems. And the outcomes could be tested with lower cost, fast induction, and minimum training, and with limited infra. That would be the partners to make India Atmanirbhar in the defense sector. Thanks so very much. In the ending, I sincerely appreciate the efforts put in by FICCI and SAMDES, and I thank the large audience of Air Warriors for giving me a patient hearing on our plans for meeting Prime Minister Modi's vision of a high-tech Atmanirbhar Bharat. Jai Hind. Thanks.
Thank you, Vivek. That was a very, very interesting presentation. Those of us who are technologically inclined, we took away a lot of it from. I'm really looking forward to having a separate conversation and learning a little more.
Please, sir, look forward to it.
Now it is my pleasure to invite Professor Julia Sutcliffe, who is Chief Technical Officer of BAE. BAE does not need any introduction, and I personally know BAE very well, having worked together on many projects. So Professor Julia, over to you.
Can you see my screen? Is that sharing with you yet?
It came, but it went, so.
Okay, just one moment.
Nanda, can you share?
Yeah, maybe from the Secretariat we can do. If there is a difficulty, we can do from them. Yeah, it is coming. Okay.
Have that?
Yeah, it's there.
Okay. Okay, fantastic. Okay, so thank you so much, Mr. Chairman, for your introduction, and hello to everybody on the call. It's a great pleasure to speak with you at this prestigious event. And over the next 10 minutes, I'd like to share with you some of my reflections and anticipation of what AI can bring to my industry as we enter this really new, exciting era for air power. I hope you will enjoy the talk. For those of you who may not be familiar with BAE Systems, our proposition is to enable defence forces with some of the most complex systems in the world today. And to do this, we work with a large ecosystem of partners, both industrial, academic, suppliers and institutions worldwide. Let me just get rid of that, sorry. And so the impact of AI, not just on our products, but on the way that we create them and the skill base we require are extremely important topics for us. As you can see, BAE Systems and its predecessor companies has a rich history of working with the Indian Defence Forces. And as each of these systems brought new capabilities and new technology to meet an operational need, we turn our thoughts now to the present day and the opportunity that is presented by artificial intelligence. So the first thing to note is that we find ourselves in an era of unprecedented disruption. Political, legal, economic, societal norms are changing. Our adversaries are employing sub-threshold warfare, unconventional tactics. The rapid maturation of the fourth industrial revolution technologies, cloud, cyber, Internet of Things, big data, and of course AI, is being fueled by an eye-watering level of investment from the tech giants. PwC reported recently that Amazon's investment in R&D last year was more than the total global investment in defence R&D. This is causing shockwaves through defence. So Dr. Will Roper here, former Assistant Secretary of the US Air Force for Technology Acquisition and Logistics, has been much reported in his efforts to transform defence culture with the application of AI. Indeed, General Sonic Carter, Chief of Defence Staff in UK MOD, identifies this moment as transformational and the most significant change in UK military thought in several generations. And you've got the NATO Director General there, Marcia Genoa, who said that AI is the single most important topic on which we must collaborate. In other words, defence industry must disrupt or be disrupted. And there's no better example of this inflection point between the industrial age and the information age that I can give you than in Team Tempest. This is a joint UK MOD industry team programme to establish the future combat air system for the UK. The proposed system of systems has to be flexible, so manned or unmanned. It has to be upgradable in terms of its sensors and its payloads. It's got to be capable, able to operate in a data-rich, mosaicked battle space. It has to be affordable, so compelling not just to the adversary, but to the taxpayer. And it's got to be connected and cooperative and able to operate in that congested and contested environment. So to realise this, we've got to transform our approach within the industry from that linear design, manufacture and support approach to an agile, rapidly capable environment so that we can enhance quickly. I think Dr. Tom Killian, Chief Scientist for NATO, said that with the F4 Phantom, 20% of its capability was in software. With the F-35, 80 to 90% of its capability is in software. And when these kinds of products enter service, you're almost getting the entire capabilities through the software load. And when I think about this kind of product in the future battle space, the kinds of scale of data, we're in the exabytes territory. And so old notions of a 20-year development timeframe and decades of in-service lifetime and large expensive upgrades are gone. But against the backdrop of such huge volumes of data and uncertainty, we need AI. And indeed, AI can transform what we do across the life cycle. Today, AI techniques are really good at looking at vast amounts of data quickly, at identifying patterns, defining trends, making recommendations and predictions. It can undertake tasks with prescribed, which are repeatable actions with really high degrees of accuracy. And there are a plethora of techniques available. So in design and manufacture, for example, generative design of components and structures through the use of genetic algorithms is allowing us to optimize designs, optimize in a multi-dimensional trade space and create solutions that couldn't be designed by a human, couldn't be built by traditional methods either. Deep learning applications in computational engineering topics such as fluid dynamics, structures and electromagnetics are allowing us to optimize the processes. Machine vision, pattern recognition algorithms for inspection and cobotics are also prevalent in what we do today, allowing us to optimize the processes. In the field of sustainment, we envisage a complete end-to-end digital thread. So platform health monitoring, intelligent logistics, again, improves efficiency. We're deploying machine learning to run after-action reviews so that we can link failures to root cause through unsupervised learning. And coupling with natural language processing, AI can provide an opportunity to crunch down operator query times and maximize operational efficiency in the maintenance sphere. And if you widen the aperture slightly further and you think about training, as was mentioned in the introduction, achieving and maintaining competence is costly. So we can apply machine learning algorithms to not just selection, but also through supervised learning to identify where a student might need some support and so that we can plan our training interventions. And indeed, in mission planning, analysis and execution, this is a vast opportunity for AI application. And indeed, we envisage an AI cockpit. We have a virtual assistant that is making cognitive workload management decisions. We've got natural language processing, which means interaction with the virtual assistant is intuitive, it's rapid. It uses control cues from natural voice, but also using sentiment analysis with things like eye tracking and physiological monitoring. It can classify pilot state, pilot stress level, so it can adjust the degree of machine processing versus human processing at any one time, a key part of that human-machine teaming regime that was talked about in the intros. So AI will help us transform right the way across the life cycle. If we think about the wider battle space, we've got a really diverse landscape, as we've all alluded to, of digital, cyber-enabled connected assets, in which every domain from space to underwater across cyber and information is a potential frontier of conflict. And novel effects such as swarms, hypersonic systems, complex directed energy systems and countermeasures proliferate. With multi-domain operations, agile C2 and cognitive networks of sensors, this is going to be the norm. This will only be feasible if we can underpin it with AI. Neural networks and heuristics will be absolutely critical to enable cooperative mission management in that sort of swarming environment and the unmanned manned teaming scenarios. Feature recognition, we've heard about massive amounts of data, synthetic aperture radar, cognitive electronic warfare will need neural networks and supervised learning to classify, identify targets and correlations that wouldn't be discernible to humans. An AI that can detect insights, patterns of life indicators from vast, disparate sources of data will be critical in the defense against very high speed threats in that left of launch scenario. And of course, AI systems that can detect breaches in security and enable system resilience will be critical. So the near future will be underpinned by AI, not just in the products that we create, but in the way in which we create them. Clearly, there are some challenges. So I'd just like to finish by considering those. As you will know, there are many AI algorithms in the toolkit that already exist today, but some challenges for our sector. So ethics, trust, safety, and cyber resilience are well-published challenges. How do we generate assured outcomes that are repeatable, that are trusted, and that are explainable? So can we trust AI to monitor a system, to recognize features, to recommend a route, or to launch a weapon? And we're seeing ethical principles and conditions of use starting to emerge with nations and organizations codifying their approaches and their strategies. The US DoD recently released its principles focused on 5 tenets of responsibility, equitability, in other words, minimizing unconscious bias, traceability, reliability, and governance. And these things are easy to say, but difficult to achieve in this global environment, which is disaggregated. We have lots of different organizations in the supply chain. We have real issues around data provenance, and we have a contested operational environment. Leveraging commercial AI technologies, as we heard in the intros, is critical in defense. We've got to be able to, with agility, leverage the innovation in the wider ecosystem and that massive investment from the tech giants. We'll need a digital backbone that allows us to collaborate effectively using cloud technologies across the ecosystem. And of course, we'll have to transform our skill base, augmenting traditional engineering skills with new skills in AI and data science. And we know competition for those skills is fierce. And we'll need to move to an agile culture in which the evolution of technology happens rapidly and we don't have 20-year life cycles and upgrade cycles. So to close, I would just say that AI offers a promise of a completely new era. There are some real challenges that we have to address, and we'll only be successful if we can do this collaborating across industry, across the ecosystem, with governments and with air forces and defence organisations alike. I thank you for your attention.
Thank you so much, Professor Julie. It was very informative presentation. I'm sure there will be many questions which others would like to get in touch with you later. We thank you once again. Now it is my pleasure and honor to request retired Lieutenant General David Daptula, who is Dean of the Mitchell Institute of Aerospace Power Studies, to give his expert comments. General David.
Thank you very much for that kind introduction, and good afternoon, ladies and gentlemen. It's a real pleasure and a privilege to be with you here today. I don't have a set of charts, so unfortunately, you'll have to look at me and listen to what I have to say. So let me start with a basic premise. Militaries around the world, as you've heard already, and realize yourselves, are in the midst of a transition from the industrial age of warfare to the information age, from an age where we focused on individual weapon systems and inflicting attrition to one where success depends foremost on the ability to manage one's own information and decision-making while degrading that of an adversary. Now, if you accept this premise, then the potential revolutionary impact of artificial intelligence, or AI, on future operations should be readily apparent, since AI at its core is an advanced method of information processing. Indeed, a key takeaway from the recent US National Security Commission on Artificial Intelligence was that AI will be integrated into virtually all future technology in some form. Now, the US military approach to AI emphasizes human-machine teaming as a force multiplier for human operations and analysts, not to replace human operators with AI, regardless of what Mr. Elon Musk has to say, but the value added is where machines and people are not competitors, but instead where humans are freed up to execute more highly dimensional tasks. Specifically, the next generation of AI-enabled systems, as you just heard, will augment humans to deal with complexity, ambiguity, and speed. So with that in mind, there's some promising near-term applications for AI in air operations. I've got 3 general areas to highlight for you today. The first is automated operator assistance, particularly for intelligence, surveillance, and reconnaissance, or ISR functions. One approach is to integrate AI to assist operators and analysts to sort through the vast amount of ISR data collected into actionable insights at machine speeds. Some of you are aware that this was the intent of Project Maven here in the United States, which used AI to help analyze full motion video data. An alternate approach is to integrate AI on the front end of systems, requiring the operator to yield some decision-making to an AI-enabled virtual co-pilot. In this construct, AI would reduce the cognitive burden placed on pilots by automating certain functions, enabling the human pilot to focus on battle management and other tasks much better suited to human operators. Furthermore, by processing data at the battlespace edge, it also reduces the data bandwidth and storage requirements. Now, this construct was demonstrated for the first time in the US this past winter when the Air Force allowed an AI co-pilot to control the sensor and navigation systems on a U-2 surveillance plane with no pilot override. Cognitive electronic warfare capabilities for tasks such as spectrum sharing, management, link adaptation, electronic attack are another promising area. Applying AI in this realm provides the ability to execute optimal strategies and adapt to a changing environment at machine speed. This could be a real advantage. Now, the second area is unmanned systems. These are likely to see greater AI-enabled autonomy moving up the value chain of what have traditionally been human taskings. For example, remotely piloted aircraft will unlikely be able to maintain secure communications with their ground control stations in contested environments. To address this limitation, AI-enabled UAVs can detect threats and other changes in the operating environment, and then use their AI algorithms to decide on appropriate actions when they're cut off from their human operators. Taking this one step further, the United States is actively working to develop what's called loyal wingman UAVs through initiatives such as the Air Force's Skyborg Vanguard program and the Defense Advanced Research Project Agency's Air Combat Evolution effort. Teamed with manned aircraft, a human pilot can give general inputs and guidance to a swarm of UAVs and be confident that the swarm will behave as required. Absent AI-enabled autonomy, a single operator would simply not be able to manage that many platforms. Now, the emerging family of AI-enabled aircraft could fulfill a range of missions in support of advanced fighters and other manned aircraft. For example, they could act as an off-board sensor or provide additional ordnance capacity for manned aircraft. Autonomous aircraft could additionally conduct electronic warfare activities or serve as a communications gateway for the kind of combat cloud concepts of operation that are now proliferating. This last example points to a third natural application for AI, and that's command and control. The reality is legacy command and control, or C2 systems currently in use, were not designed for the speed and complexity that information age, all domain operators demand. Furthermore, the evolution toward highly centralized command and control architectures that rely on robust, high bandwidth communications will likely be disrupted during peer adversary or against peer adversaries. Now, artificial intelligence will feature prominently in efforts to modernize command and control. AI and decision support tools will allow commanders at diverse command and control nodes to better control
I think we lost the voice.
We can wait for a minute, or somebody can call him on the phone. Vic?
partners with AI-enabled capabilities. As the U.S. National Security Commission on AI pointed out, uneven adaptation of AI will threaten interoperability and the political cohesion and resilience of U.S. partners. Given the problem-specific and data-dependent nature of AI technologies, cooperation with partners and allies requires working through common objectives and common equipment. It will also be critical to accelerate agreements on architectures and standards, share technical expertise, and pursue AI use cases for exercises and war games. At the same time, peer competitors are investing heavily in artificial intelligence. As you're well aware, China seeks to be a world leader in AI with an aim of making the industry worth billions and billions of dollars. According to China's 2019 Defense White Paper, quote, the form of war is accelerating toward informationalized warfare evolution with indicators intelligentized warfare is emerging, unquote. The Chinese People Liberation Army objective is to use AI algorithms, machine learning, human-machine teaming, and autonomous systems collaboratively to paralyze its adversaries. Seek to use sex to immobilize their adversaries while defending their own system of systems. And Russia is similarly pursuing AI-enabled capabilities, with President Putin notably stating that, quote, whoever becomes the leader in this sphere will become the ruler of the world, unquote. Given the wide proliferation of AI, it's unlikely that some technology breakthrough alone will provide a sustainable advantage. Instead, success depends on combining concepts with technology. To date, much of the focus in fielding AI and autonomous systems have focused on improving current ways of operating. Mosaic warfare is an example of a current U.S. Department of Defense effort to combine cutting-edge technology in AI with new operational concepts to achieve a more enduring military advantage. Mosaic warfare offers a comprehensive model for systems warfare that encompasses requirements as well as acquisition processes, the creation of operational concepts, tactics, techniques, and procedures, and force presentations, as well as force allocation actions, in addition to combat operations. This concept combines AI-enabled command and control with more disaggregated manned and autonomous units to enable the military to execute faster and more adaptable operations relative to an opponent. Now, where these advantages stand to show the greatest promise is in the air domain, as that is the domain that provides great perspective, freedom of action, and that's absolutely critical to control for the success of physical operations on the surface of the Earth. So with that, thanks again for allowing me to present my perspectives here to this great conference. And I wish you all the best of success in the remainder of the day and in your respective endeavors. Good day.
Thank you, General Deptula. Appreciate your very informative session. Now it remains my duty to request my colleague and co-chair of FICCI Defense Committee, Mr. Sudhakar Gande, to propose vote of thanks.
Thank you, Shuklaji. And I must say, I'm very delighted to propose vote of thanks for such a very interesting, informative session, possibly one of the best sessions we have organized. I've attended personally in the recent times, including the excellent panel we have. Before I formally propose a vote of thanks, I would like to inform gathering that we have more than 500 participants who attended this program across the globe, not only India, making it an extraordinary success. And I would also like to give certificate appreciation from FICCI point of view, as Mr. Shuklaji explained earlier. This is the kind of thing we give to our participants. We would like to give a certificate of appreciation to Mr. Vivek Mithal for participating and speaking in this session, and also Professor Julia Sutcliffe for participating in this session. We would like to thank both of them for participating in this. And as I said earlier, I was extremely delighted with this program today. On the welcome note, Shuklaji covered very clearly how the industrial revolutions happened. First, second, where we were colonies of the world. But third, we played an important role being a technology. But today, fourth revolution, which is substantially on the digital plane, where machines will start talking to each other, maybe what we call industrial 4.0. But at the end of the day, data is extremely important in this, and data collection, data assimilation, analysis, all this put together drive the AI to the next generation. And AI should require a lot of amounts of capital invest and to handle the big data. And no country can single-handedly handle. That's what the point Shukla highlighted. And possibly integrate AI into the overall policy of the government and strategy of the government of building a Atmanirbhar Bharat for the defense sector. And after that, Admiral Dhawan, who was the founder of SAMDES, and his thematic address, as usually clarified very clearly how to leverage AI to win the wars in future. And also how to get the role of, he also explained the role of SAMDES in terms of achieving technological superiority in air forces, in armed forces, and also promoting Atmanirbhar across entire defense sector. He talked about leveraging AI in Air Force, particularly from a point of view of sensors to shooting, and also controlling the airspace management. He talked about several critical components, but at the end of the day, he talked about the smart systems, how they have to be developed, which get experts across the space to ensure systems which develop to track the targets, move the targets, destroy the targets, and the systems become more and more accurate. This is the points he highlighted. Of course, after that, Air Marshal R.K.S. Bhadauria, very, very crisp and clear. And the point he really highlighted was how traditional warfare and Air Force was, technology was the first absorbed in military, then it was given to defend other sectors. But AI is one technology which started everywhere, including defense, and possibly in some areas they could be lagging behind. And he posed questions to the entire seminar for today, how the algorithms can be made more improve the combat strategies, and also how machines can become more effective. AI can make machines more effective in combat aviation. He also had asked the conference to look at the trust deficit in terms of situation, when situations are becoming more and more dynamic, how solutions are driven by an AI or a man, how both these things need to be looked at it. And he particularly talked about the specific relevance of AI in defense in terms of on the maintenance side, how they are using the AI systems to improve substantially the digitization they have done, they improve the inventory management. And he also talked about how working with the Indian industry, it's very heartening to know that they are working more with Indian industry rather than global industries for building some of these systems. And he also talked about how AI should be used for upgrading the networks and also potency tests, etc., how it can be absorbed. Finally, talked about it's time for the industry to work with them in areas like training, exceptional combat situations, and also smart technologies in AI, which can be absorbed by defense forces. And the next generation AI enablers or air warriors, these are the issues he has thrown open to the conference to address. And he's looking forward very keenly on the AI development from this perspective. Then we had a quick session or presentation by Vivek Mittal, very interesting. He talked about how mission philosophies for next generation AI warriors. He talked about
Pandit Sahab, we will have to be little briefer, please.
Yeah, sure. So he talked about his own company's experience, how they worked on the US defense military side. And he also talked about predictive maintenance and how operational efficiency can be improved. So possibly, I strongly recommend Vivek to work with other Vivek to maybe have a session on some of these programs in future. Professor Juliana Scutliffe's program was extremely good. She talked about a lot of technologies, but something of extremely importance is how a new generation aircrafts are going to change the world, how AI being utilized in these things, how the industry has reached the inflection point. So this is something for us to understand. And one interesting data she left with us, in F-35, we have close to 90% of 85 to 90% is software compared to F-18, which was 30%. So the things are becoming complex, and it gives you a lot of opportunities for the industry to come up on speed. She also talked about interesting concept of AI-driven cockpit, where a virtual assistant will help the manual pilot, the personal piloting the aircraft to be more effective, etc. And finally, Dev Daptule, US experience, he talked about it. It's very brilliant and precise, and I must say very deep, how US military is planning AI as an instrument. He talked about specific areas to focus, but what one point he left with us is how the machine and people are not competing. They have to work together to make AI more effective. And also the world is going to be definitely AI-enabled aircraft, which are going to be more advanced in being effective. And finally, the point he left is very interesting for India as a country and all of us to think how China is planning the AI strategies, how Russia is planning AI strategies, possibly the food for thought for all of us to look at how India can possibly program some of these things. With this, I must really say thank you very much. It was a very, very interesting session. I would like to thank all the participants, and also I would like to specifically also thank FICCI team led by Vivek Pandit and Vaidyanathan for assembling the whole thing together. I also would like to thank Sandel team by founder R.K. Dhawan, Admiral, and also Honorary Secretary Commodore Sardar. And again, I want to repeat that the participation was extremely good. We have more than 500 people across the globe who participated. Sorry for taking a little extra time, Chairman Mr. Shukla, but with this, I will conclude my vote of thanks. Thank you very much.
Thank you so much.
This takes us straight to the next session. I'm sorry to jump this. We are about 13 minutes late. So it's my pleasant duty to now request Air Marshal Bhavnani to kindly lead us into the first technical session on models, algorithms, and applications. His bio is on the screen, and over to you, sir, for conducting session 1. Thank you.
Thank you, Sujit. Can you hear me clearly?
Strength 5, sir.
Okay, thank you. Greetings and a very warm welcome to all for this first session of the symposium. I think the inaugural session has really been a very exciting one because the topic itself is so exciting, and it's been also very inspiring. We had the chief talking to us about how the Indian Air Force proposes to move forward by getting most of its large number of its assets into AI-enabled systems and improve their efficiency and have benefits of all nature.
Mr. Gandhi, can you mute yourself, please?
Okay, so the subject for this session is on AI models, algorithms, and applications. And just a short while back, I thought I'll give a short and simple definition of artificial intelligence, since this is the first of the many symposiums to come. And I was fortunate to find on the net a rather simple definition, which I thought I'll share with you. And it says that artificial intelligence is the ability of machines to think like humans and to ensure that not only think, they think with reasoning, not with mechanical responses. I just want you to focus on this point, that is, you think with reasoning. And that's the change that has come about in today's world, where artificial intelligence is not only being widespread in the civilian market, but also in now moving on to the military market. And now we're going to get on to discuss how it's going to affect air war fighting in the future. One of the reasons why the definition says think with reasoning is where the AI has elevated itself to the very next level of technology. And this has happened because, you know, computers and chips have now got computing power, which is so extensive, which can data analyze the huge and mountains of data that's available in speeds which were earlier unthinkable. And when you put all these factors together and when they converge, what the result is that you have algorithms which are now so highly improved that they optimize all the requirements of today's military utilization. Do we need you know, for AI um, for operations, for target information? All these have been now optimized essentially because algorithms have reached a very high level of working and being able to pinpoint the tasks that they are given. And I'll give you a very basic example of these improvements in the algorithms. 2-3 decades ago, there was smart pilots helmets. You know, the helmet has a visor, and on the visor you have all the information that you require to fly the aeroplane. That was 2-3 decades ago. But today, the whole entire aspect has changed. The information that's available, that's generated on the screen, on the visor, is so widespread that there are a multitude of functions that can be displayed to the pilot, and he doesn't have to look inside the cockpit. And that's the huge change that's come about. And this is just one of the various applications of artificial intelligence enabled systems that are being looked at for air warriors, and you will hear more of them in the symposium as we follow on. For this panel today on the subject which we mentioned, AI models, algorithms, and applications, we have three highly professional and distinguished speakers. And without much ado, I'd like to introduce the first speaker, and he is Mr. Anurag Rana, the Senior Vice President of New Space Technologies. And he will be speaking with us on building trust in algorithms for air combat. I think this is going to be a very interesting subject. And I'd like to hand over to Mr. Anurag. You have the floor. So just 10 minutes, please. Thank you.
Thank you very much, sir. I'm doing an audio check. Can you hear me?
Loud and clear.
Yes,
Loud
yes,
and
we
clear.
can hear you. Please, loud and clear.
Thank you very much. And I believe my presentation is also live. So with that, thank you very much. Thanks to well, my distinguished panel, and welcome to all the dignitaries from India and all over. My name is Anurag Rana. I'm Senior Vice President, New Space Research, NRT, and I will be covering the implications of human trustability in air combat AI operations. The air combat AI operations are going to be governing a very wide spectrum of operations, most notably for the UCAVs, the loyal wingman strategy, which is emerging, fighters which are going to become optionally manned, and also the electronic pilot associate system, which is going to be some sort of a decision-making system for the pilot. Now let's take a look at a couple of spectrum of AI, and we are going to plot it on a 2x2 matrix on an XY spectrum, where we'll have the potency on the Y spectrum from a low to a very high potency, and then the explainability of those systems to, let's say, for a human via an algorithm, which is going to be from high to low. So you can see that this is actually a downward going trend. And on this, when I plot some simple algorithms and intentionally taking examples of board games. The game of tic-tac-toe has a very simple algorithm, which is a flowchart based. It is something which is very, very simple algorithm and easy to understand. And let's say when you want to go from tic-tac-toe to a game like chess, for which an AI program was able to beat Gary Kasparov by Deep Blue, one of my co-panelists also talked about the Deep Blue system equivalent, then this AI was broken in right about the 90s, and this was done by, while the algorithm was still easy to understand, it was a straightforward algorithm, but it was so computationally intensive that it needed a supercomputer, and still it was not happening in real time. Now we are coming to problems like the game of Go, which was said to be something which was unsolvable, but the AI was able to solve it through neural networks, which are highly potent. So that is why it has been plotted on the highest quadrant of high potency. But these are black box models. They're neural networks, and there is no way that the logic is something which could be written like a flowchart for a human to understand. So now the question is, do we really need to understand the AI logics? Now, for example, not everyone knows how an IC engine works, but people still drive cars and they trust it. So that is where the role of the regulator becomes important. Now, the problem is regulation, which in this case, the agencies which have to do V&V and certify the systems, they have not been able to catch up with the pace at which AI has grown. And regulators do not even know how to do V&V for a black box AI. So what do we do now? This is compounded by problems. For example, the Chinese are saying we do not really want the ability to trust our AI. What we want is we want to overwhelm by having a lead in this, trust can follow later, and let's just have a large number of these very competent and potent systems, put them in the fray, and then we'll see. Now, the right way to go about it is something which DARPA is doing, which is obviously they're going across with their ACE program, which is part of their overall Mosaic warfare, which is something which again we talked about. And this is divided into multiple technical areas. The biggest area which was shown to the world last year was dogfight algorithms in a simulated environment. However, this is just one part of multiple technical areas which they're doing, which includes scaling to Mosaic and also scaling to a full-scale platform. But they have one parallel area, which is how do you measure trust? So I want to briefly touch across on this trust measurement. So DARPA has a parallel track known as XAI or explainable AI, where going from, let's say, training data to a machine learning process to a learned function, which a human does not really understand, the idea is to go to what is going to be called as an explainable model, but also an explanation interface where you can interact with the AI and saying, why did you say so? I mean, what are the options that you considered and you picked this one? Now, before we go into this XAI, enough has been talked about the OODA loop, but how the OODA loop transfers to, let's say, a thinking solving machine is it goes from a sensor to a perception to a plan and a control mechanism. So this is the kill chain also, which goes from the sensor to all the way the control. But the whole idea over here is rather than at this stage, AI completely take over the airplane, let it just process all this information and form and reduce the cognitive load by pre-processing it and simply giving it a couple of options for the pilot to take some sort of decision making. However, having said that, again, the question of trust comes. So right now in the sense and perception cycle, we have taken some work to come across with our own explainable AI, something which I will cover. In this sense and perception, the computer vision and machine algorithms right now, rather than being a black box where they simply produce an output saying, I have spotted this target, this is what it is, we are dividing, and this is somewhere I'm showcasing original NRT work. We are dividing these into very feature-rich individual features. For example, this airplane has been decomposed into features of there's a fuselage, there's a tail, there are wings, the wings have engines, the probability of these engines being detected, there is a landing gear, and then these are represented in the form of a graphical neural network where the fuselage is comprising of wings which are comprising of engines. So this way of capturing and representing information that we are able to decompose and present it to a human in what is it that we are perceiving and then do the decision making is some of the work which we are doing at least in one layer, which is the sense and the perception layer. Going from here, once you pass on to this to the control part, now when the state is being estimated of, let's say, in a 1 versus 1 combat where the computer program is analyzing what is the relative state of my enemy vis-a-vis me, and the neural network predicts that the throttle, the roll pitch, your command should be so and so to control, these four vectors of throttle, roll pitch, yaw could also be translated into a 4 vector of a velocity vector, which is going to be the magnitude and 3 dimension and the 3 XYZ components. And in this way, when this is presented, the pilot is able to see a trajectory out of multiple trajectories and can query and say, okay, computer, you are suggesting the following options, and based upon, let's say, your best recommended course of action is to take this trajectory and okay, I accept it. It's a command decision. Please go ahead and execute. So in both of these cases, the computer through sense perception, command and control is keeping the human on the loop, but it's presenting the information in a human understandable way, both as an explainable model as well as an explainable interface through which the human is able to then do the executive command decision. Taking this ahead, the current new generation of AI technology, which is heavily backed by something known as graph neural networks, where knowledge is represented by graphs, and these graphs are then represented in a manner which the human is able to understand across, let's say, pre-processing, processing, and suggestions, is a new technology which we are absorbing, which we also recommend that be absorbed. And as I gave an example, something we are doing in our computer vision and machine learning paradigm. Now, I will come to a framework of trust measurement. Frameworks of trust exist, at least trust in automation. So this is not a new science that has been going around for some time, and it is a very iterative loop. It essentially talks about that within a context and based upon the pre-perception of an operator, which sets a certain expectation, trust is measured, which leads to reliance, which in turn affects outcome, and then it feeds back to the context. So this is sort of like a feedback loop. So the point is this trust is something which is going to build over time, and part of these can be measured just going with the DARPA program, ACE program, which has gone into now one of the airplanes being flown by autonomy and having a human operator who's correlating what is it that the AI pilot is doing, and also measuring whether this is leading to a reduction in the workload of the manned pilot is something which is an ongoing study. And now, what this evolves to the dynamic of trust. Trust is a spectrum which grows from starting with predictability, going on to dependability, and emerges into faith. I'll give you an example. So, animals have been a part of warfare since time memorial, and those animals are now evolving across to robots. So, similarly, there was no way that you can query to an animal, but people depended upon their war dogs and their war horses as if their life depended on it. So, that was the faith. Now, the whole idea is because the framework of trust is that, first of all, it has to satisfy that whether this agent or entity is going to operate in a predictive manner, and then can it do this again and again and again with a high degree of dependability, and that eventually leads across to faith, is a paradigm which, again, at a very abstract form, the trust spectrum could be evolved across to. Now, for this, DARPA's approach, we do believe is the right approach. What they are doing is they are evolving across phases, where the first phases are pure modeling and simulation. Now, these phases are largely complete. They showcased this last year in August and September, from where they're going to go on to scaled platforms and eventually across to full-scale platforms. Now, we in NRT, in association with the Indian Air Force, are following a similar path. We have an initiative known as the ACID program, Air Combat Intelligence Development, something which we showcased this year in the Aero India. In uh, in the Aero India, we were able to field what we call as equivalent to the DARPA phase 1 and catching up with the world's best. It was obviously sampled by the officers of the Indian Air Force, but it was also something which the United States Air Force was able to uh, sample it. And the idea was something similar. We start with a scaled and in a simulation, but go across to a full-fledged platform. In this case, the Red Force was a Red piloted airplane by a human pilot, which was fighting against a Red Force, which is a pure AI agent, which was doing a state estimation, passing it through a neural network of the type of reinforcement learning, and producing the same controls, which is throttle, roll, pitch, yaw, which in turn was going into a BVR gun versus gun kill. And this was a very, very potent technology, which is now having its own evolutionary roadmap in the sense of that parallel with an HAL program that again NRT did and fielded at the Aero India. The idea is to evolve it from one versus one to a scale platform to complete swarm operations and to demonstrate its effectiveness across something like a mosaic platform where the manned person is more in terms of a command decision and ordering the UAVs to execute. So from simulation to scale to unmanned is our paradigm, and uh, what this shall result in a trustable system. However, what it'll also need is number one for the regulators to come on board and to agree and to come across with the framework where these sort of black box AIs can be evaluated, and more importantly for the end operator, which is the Air Force, to start working on it now. when the technology is still evolving and get to know it, rather than wait for it. And the pilots will build an intuition of these systems very much the way they were able to build an intuition of, let's say, when the first instrument flights happened and then the autopilot, and now radar and BVR systems are coming across. So this cycle has to go on. This is our recommendation. And again, we start from synthetic or simulation to scale and to final platform. With that, I bring the presentation to an end, and thank you very much, and open to questions, if any. Over, sir.
Yeah. Thank you, Anurag. That's been very interesting indeed. And I think this is a subject which we are happy to know that you've been dialoguing with the Indian Air Force. I'm sure that will bring in a lot of good results, and we'll talk about that subsequently too. Thank you very much, Anurag. And I now call upon the second speaker, Dr. Chandramouli, CEO of Spectrum Technologies, and he will be speaking to us on how AI will make a difference to communications. And his subject is resilient communications for air warriors. Over to you, Mr. Chandramouli.
Thank you. So thanks for the introduction. So my topic today is how to provide resilient communications for air warriors. So let me give a snapshot of why we need resilient communications. So from a U.S. Air Force perspective, and also from air fighting perspective, we have a situation of extremes. So we have very high speeds, more than gigabit per second data rate requirement, bandwidth requirements, and then less than millisecond latency requirements for decision making, as well as low probability of intercept detection, congested spectrum. So all this brings together the need for resilience for extreme mobile networking for the air warrior. So here is an architecture that we've been looking at, which is an AI-driven resilient multi-access networking edge computing. So currently, as you know, right, in cellular networks, for example, we had just one mobile operator. Either maybe you have a contract with Reliance or Airtel, or in the US with Verizon or AT&T. But in an air warrior situation, that's not the case. Typically what happens is the air assets have access to multiple networks. And so the goal is to combine and slice these multiple networks in real time for the best application performance. So what we see here is a predictive optimization architecture. So instead of trying to be reactive, so what we are proposing is that your AI algorithms was able to predict, for example, 2 minutes, 3 minutes, 5 minutes from now, what's going to be the wireless bandwidth or the signal quality on a free space optical network, FSO, or on a 5G or on a SATCOM. So based on these predictions, as well as what's going to be the available computing power to do very high resolution video analytics or other sensory data analytics. So based on these predictions, the idea would be to allocate resources. Therefore, we minimize latency, maximize bandwidth, low probability interception, and so on and so forth. So, and also this is a distributed computing platform where you have computing on the maybe on the drone or on the aircraft, in the ground. Maybe the aircraft is talking to other aircraft, so that you could have a flying Amazon-like computing cloud, and so on and so forth. So how do we manage this dynamic situation, both in terms of networking as well as computing? That can be done with AI. So one of the key challenges then is to get real-time measurements, because when you're doing anything real-time with AI optimization, you need to have, of course, be able to sense and sample the operating environment and be able to adapt quickly. So one of the things that we have been building, also built and demonstrated, is a full stack measurement architecture, which is we measure all the way from the wireless spectrum all the way to the application. So how good is the signal quality? How congested is the wireless spectrum? Maybe there are multiple networks, so we measure all the networks. What's the downlink, uplink throughputs? What's the latency? What's the CPU? And also, how is the video? For example, if you're doing full motion video, is the video quality good enough for the air warrior application, right? So all this done is dynamic. So we measure close to about 100 variables. And then use these 100 variables. So it's a very high dimensional data set, and we process it in real time using some deep neural network architectures. So one of the applications for this is what we call the dynamic multi-axis dynamic bandwidth aggregation and network offloading. So the idea here is you have an aircraft that could have access to, let's say, an FSO network, which has X megabits per second, maybe a 5G network, Y megabits per second, and a SATCOM, another Z megabits per second. So let's say it's 10, 10, and 10. So the goal would be, if the full motion video application requires 30 megabits per second, we'll be able to combine all these three networks virtually. So to the aircraft, it looks like it has a 30 megabits per second link, whereas underneath you have three separate links. And then the application says, well, I don't need 30 Mbps anymore. I need only 20 Mbps. We can let go of one link and then bring the other two links together. And also, if one of the links has a lot of interference, the algorithm can sense and then move the application to other links dynamically so that the application is never interrupted and you have all the quality that's required all the time. The other technology R&D challenge is how to use AI for real-time reasoning and inference in an extreme wireless networking environment. So for example, when you're doing this dynamic shifting from one network to another network, one of the things that the algorithm must not do is premature network selection. So maybe it thinks that a SATCOM network is pretty good. It prematurely connects to that, but then it loses connectivity. So it must be, that's why I said this predictive optimization is the key. So you need to say, well, now my link is good, I have good bandwidth, but 2 minutes, 3 minutes, 5 minutes into the future, will that exist? So that sort of predictive optimization is necessary. Also, the algorithm could choose a wrong network. So for example, you could have a very good signal strength, but whereas the backhaul could be highly congested. Maybe there are multiple aircraft sharing the same backhaul network. So that needs to be mitigated. Or the algorithm could use the wrong network to offload. Okay, so that must be mitigated as well. Or it could be unstable network choices. So if the algorithm is choosing between, let's say, a SATCOM and a 5G, for every 30 seconds, it's shifting between one network and another. That's a very unstable network choice, and that's not good for the application. So these are all technical challenges that needs to be solved algorithmically from terms of software stack implementation and also policies that's set for controlling these networks. So some of the features that we require are the platform must be agnostic to the wireless spectrum and standard, because you cannot design an AI engine for each and every network separately. You cannot have one engine for LTE, one for Wi-Fi, one for 5G, one for SATCOM. That's not good. It's not scalable. So we need one controller, software-defined controller that collects all these measurements and must be able to control multiple networks agnostic to the wireless spectrum or the standard, so it's future-proof. It must be able to offload computations on any edge or a cloud. It could be a simple Raspberry Pi, or it could be your Amazon cloud, correct? So it should be able to scale quite rapidly. Must be application aware. So for video application, for data application, for a voice application, they all have different requirements. So, doing networking just for the sake of networking, it's old. It's an old thought. So what's emerging now is it's application that drives how networking must be done. So you take the application requirements and then drive networking based on that. And of course, as I mentioned, we need to be predictive. So there's continual deep learning, forecasting, adaptation, and end-to-end optimization that happens. When I say end-to-end, all the way from the aircraft to maybe a ground station where the full motion media is being analyzed and then sent back to the aircraft, right? So this complete loop is optimized in real time. So maybe I'll present the next 3 case studies before I conclude. The first case study is what we did for the US Air Force. So this is a policy-based resilient dynamic spectrum access network. So the idea is when you have a congested and contested wireless spectrum, how do we identify congestion and contention and be able to shift the connectivity to a different spectrum band altogether without losing connectivity? So session persistence is the key. And we were able to demonstrate to the US Air Force that using this technology, we can actually double the number of connected air fighters given the same amount of congested and contested spectrum, right? Because AI is using this predictive AI techniques, we're able to we can achieve this. So this was recognized by the DoD as a success story, by the U.S. National Spectrum Consortium, also recognized in the U.S. Senate testimony by the director of NIST and also the U.S. Undersecretary for Commerce and Standards. The second case study where we put this to a live test was the Boston Marathon case study. So we worked with the Brookline Police Department to do a live resilient video streaming for law enforcement. As you know, during Boston Marathon bombing, all the cell towers were congested, so people were unable to make phone calls. So even public safety were unable to make phone calls or talk to each other for search and rescue after the bombings. So they're asking people to actually send text messages to reduce the bandwidth consumption or the congestion on the cell networks. So in order to avoid that issue, we deployed this and then demonstrated to them that if the Verizon AT&T towers were congested, we would still be able to, using our technology, be able to provide voice and video communications to public safety. It's completely contained in a box, so even without any external backhaul network, they'll be able to talk to each other, right? So without any internet connection. So again, of course, if the AT&T towers are bad, then we'll be able to connect remotely as well. So that is the second case study. So the feedback, of course, right, as it says, Scott Wilder, Brookline PD says that this technology is an insurance policy that first responders always have what they need, regardless of the connectivity. And so again, that's the key for air warriors as well, right? You could lose connectivity or the connections may not be all that great, but you still need to be able to deliver the application that air warrior needs. The third case study is we deployed this for the Indian Railways, the Tejas Express. This is from Mumbai to Goa. As you know, the train passes through the Western Ghats. It's a very challenging environment from a wireless perspective. So there were 3 wireless operators. I don't want to name them. So these are actually real measurements we did. Mobile operator 1, 2, and 3. We found that each of the major Indian mobile operators, the coverage was less than 50%, and most for majority of the route, they were able to provide less than 5 megabits per second speed. And that's not good enough, right? In a train, you have, in a coach, for example, in Tejas Express, you can have up to 40 people. So 40 people trying to share a 5 Mbps, it's not good enough. So what we're able to show with this technology is that we can reach a peak download speed of 90 megabits per second, on an average 22 megabits per second, and a peak upload speeds of 87 and average upload speed of 17. So which means multiple people in the train, they'll be able to do WhatsApp calls, they'll be able to watch YouTube videos and so on, even when the train is passing from Mumbai to Goa or the other way around. So to end my talk, so of course we're looking for technology collaborations with the Indian enterprises. So with, we would like to leverage the Atmanirbhar Bharat program, and I foresee several addressable markets in India. It could be the Department of Defense, public safety, connected transportation, smart cities, rural broadband, and smart agri-tech. So here's my contact. I'll be happy to talk to anyone who's interested. Thank you.
Thank you, Dr. Chandramouli. That was a very creative perspective of communications, resilient communications. As you know, our militaries, Air Force, Army, Navy, they're all, dispersed out in very far off locations, and we've always had problems with communication. So I think there's a great possibility for you to talk to the services and see where you can step in and get your very high-tech stuff going and assist and support the services in communications. Thank you very much once again, Dr. Chandramouli.
Thank you.
For the last speaker, it's Dr. Ranko Sridovovich, and sorry for that pronunciation. I hope it's okay. He's the founder of Numerical Communications, based in Silicon Valley in San Francisco. He's going to talk to us on AI-enabled preventive maintenance, and I think maintenance is an issue which every commander is concerned about, because with the costs of platforms and systems going up so phenomenally, everyone wants to ensure, the commanders want to ensure that, you know, there's enough preventive maintenance so that nothing goes wrong and you don't have to, you know, cut into your budget for that. So without any further ado, let's have Dr. Ranko to give us his views on AI-enabled preventive maintenance.
Thank you very much, sir. Can we do a sound check? Am I coming through?
Yes, you're straight 5.
Excellent, excellent. Well, good morning. It's, I'm on the West Coast. It's 3 a.m. here. Very exciting conference. So thank you very much. In the introduction, I will be talking about some exciting work we're doing on machine learning for preventative maintenance with the goal of improving aviation asset utilization and reducing unscheduled maintenance. Okay. So since we're still under COVID, we cannot do this in person. This is me. My name is Ranko Sredojević. I'm a co-founder of Numerical, where I currently lead new product development, working with a cross-functional team from industry and academia with competencies in machine learning, distributed systems, and edge computing. Okay. So the Numerical's mission is to help organizations improve operational efficiency using forward deployed machine learning. So what is forward deployed machine learning, which is our biggest differentiator? It's the situation where we, instead of traditional approach where we bring data to the algorithms like cloud solutions would do, we actually turn things around and try to bring algorithms to the data, as multiple panelists already alluded to. There are a couple of benefits of this inversion in the system design. And the first one would be the significantly faster system response time. And as one of the previous speakers already noted, you might be in a GPS denied environment, you might not have good communication connection. So, you know, being able to run machine learning algorithms on board of your aircraft or your vehicle, or even on premises in your base is actually significantly better. Obviously, security of the data is significantly better as well, because data never leaves the enclosed area behind the customer's firewall. And then finally, because we're not stressing the communication infrastructure, we can actually afford to look at data at much higher resolutions and actually at much higher sampling speeds, right? So this can all be a little bit abstract when it's dry like this. So let's go into an example. This is our first case study, a system for monitoring and optimization of vehicle reconditioning operations in the United States. This is the largest vehicle remarketer in the United States. Here we see a debug view of the system. This is not the actual UI for the user. On the left is the raw camera footage. On the right is a system performing detection. Detecting the vehicle that comes into the bay for reconditioning, reading all the markings on the vehicle that are typically associated with the invoice and the source of the vehicle, and then accounting for the work that was done and how many man minutes were spent in a certain position along the line. So in this system, we have about 5 stations per lane, 1 camera per station, 3 to 10 lanes per location, and about 70 locations across the United States. The system, forward deployed machine learning, which is packaged into a computer behind the customer's firewall at each of these locations, processes the equivalent of about 280 Netflix movies per location per day from high resolution cameras, and achieves 98.8 accuracy in raw data detection. So vehicle stay durations and work orders. So this is an example of a system that's absolutely impossible to implement without forward deployed machine learning. You know, moving this amount of data into a cloud from a single location is a no-go. So no internet service provider wanted to accept this volume of data. And then using humans to do this kind of measurement turned out to be very inaccurate. Actually, the accuracy when they tried was below 50%. Right? So how does the data actually looks like when we pull it in? What we get from the basic measurement, from the low-level measurement, is basically distribution of item processing times for each location, from which we can generate real-time alerts for the foreman in case we detect some kind of station productivity problems. Maybe the car broke down, so someone needs to go out and solve that and resume the work at the station. We also can, in real time, detect quality and rework rates, so they know what's going on and whether certain station has a different kind of problem. But we also can provide data for planning and business units, because now we have the ability to measure productivity of each location, which helps their planning units actually route vehicles from a central holding location, right? So how is all this done? How do we know whether a station has productivity problems or not? Because we don't have data that's labeled for this. So what we do is we use machine learning for outlier detection, where basically by observing each station under each lane in each location, we build a predictive model of what's to be expected from a single station. And then we compare every station to the predictive model to find the ones that are overachieving or underachieving, and then we report that. So the same principle of training and basically a model, predictive model of what's expected, and then giving feedback to humans to inspect things that are outliers to the model actually works for manufacturing defect detection, and specifically for surface defects like scratches, cracks, and blisters, which I think is very relevant in aircraft maintenance. So here we're showing a system that looks at the surface of metals and points out areas that it believes are incorrectly manufactured. And the same process by which I mean training on known good examples of modeling the distribution that's been seen so far, and then pointing out to a human that there is something that's different coming through, also works in electronics manufacturing. And here I'm showing a printed circuit board example where the system is highlighting what it thinks is incorrectly manufactured conductive layer. Okay, so with these technologies, we now want to build a new product, which is machine learning assistant for predictive maintenance. We specifically want to focus on improving aircraft fleet utilization by anticipating and programming maintenance to optimize availability. The idea is simple: to apply the same technology I talked about in the previous couple of slides. So that is, monitor every asset in a fleet, build a model of what's expected from a asset in a fleet, and then compare each concrete asset to the model to find the ones that are outliers and that we should that we're going to suggest for humans to take a closer look at. Obviously, later integrations with of long trend monitoring and even manual rule-based maintenance operations can be integrated with this easily. The best place to start, in our opinion, is with aircraft engines, with the explicit goal of reducing unscheduled removals. So to do this, we're looking for partners within your program. Two kinds of partners: obviously customer organizations such as Indian Armed Forces and specifically Air Force, where we would seek to do a pilot study on aircraft engines. The best place to start would obviously be some kind of asset where there is a good available maintenance data, and deliverable would be a prototype of this assistant for predictive maintenance. The other kind of partners that we're looking for in this project is technology organizations, whether they already exist in India or they would be subsidiaries and partnerships through Vega and MX and Numerical, with the goal of establishing local domain expertise and skills to build out predictive maintenance based on machine learning, both for Indian market and for global applications. So the outline of the project we can envision here is to agree on a core business model, which institutions would be partnering, and how the solution be co-owned. Then there is a typically forgotten but very big chunk of work in reviewing and specifying procedures for systematic data collection, labeling, and curation, which would include installation or upgrading of the sensors, digitizing of all the teardown data, so we have ground truth for training models, digitizing operating logbooks, and then obviously training and acquiring expert knowledge for these kind of tasks. And then finally, Once we have those models, once they can actually produce outputs, we need to figure out how to integrate all this new kind of information in existing dashboards and reporting tools and make it usable and actionable by maintenance crews that are used to certain kind of interaction with their tools. And with that, I would close my presentation, and thank you very much for your attention.
Thank you very much, Dr. Renko. That was a very excellent expose on predictive maintenance. And this is, as I said, the subject is of great importance to everyone in the Air Force, particularly. And we'll talk about that. But thanks very much for your presentation. I know it's early morning with you, and you had to make it here with us at that time, but we appreciate it very much. Thank you. We can now start with the
quickly
Q&A
come to
session.
some. Yes, sir. We have 3 questions which have come up on the Q&A, so I will just read them out, sir, and you could ask our panelists to respond. The first one is on trust, which was mentioned by Mr. Rana, and he had said very clearly that the situation of trust has to be developed before AI can be delegated autonomy. Could we request him to list 4 to 5 factors by which trust can be developed by the users in the Air Force for AI applications, given the caution that was mentioned in the inaugural session itself? That's the first question. For Mr. Morley, there's a question on what is the present status of free space optical communications in the US, and how that would make a difference for resilient communications for air warriors. For Mr. Ranko, there is one question here where he's brought out different case studies, which appears that they only need to be modified. So this is a little difficult, but I'll put it here anyway. It says, how much of an effort or resources and support is required from the IAF to investigate crack propagation and engine health prediction? These are the 3 questions that we have for this seminar. We have barely 4 or 5 minutes, so we'll have to request for quick responses, sir.
Yeah, okay. Dr. Anurag, could you get on to the first question? Have you recorded it?
Indeed, sir.
Yeah.
I've been able to hear it. Just doing a radio check, sir. Can you hear me?
Yeah, we can hear you. Strength 5.
All right, sir. Thank you very much. Sir, I will actually merge 2 inputs which we received in the inaugural session, obviously by Air Chief Marshal Bhadoria, sir, who talked about that there are basically 2 issues. Number 1 is not only how do you trust this, but obviously the question of ethics in terms of whether the target in this particular case, in the case of, let's say you don't have an IFF, do you decide upon whether do we fire it or do we not fire it? How do we get that reliability? And the second is just to complement it, as was said by Lieutenant General David, who talked about that the AI will not replace the human, it will also augment the human. So in any case, the command decision still remains with the human. And that also addresses the ethics part, that in the end, in such a scenario, who's going to be responsible, the sensor, the person who made the sensor, or the person who made the algorithm? So reliability, liability, accountability still for the human, and these are all decision enhancing. So the one way to do that across over here is obviously to have a multiple sensor fusion, which in this case do not rely on a single sensor. So complement, let's say, an optical sensor with a radar sensor, and within the optics also an UIR. So the answer to that is obviously have multiple sources of data from a single platform, but also from multiple platforms. In any case, in future, we are looking at a paradigm of some sort of swarming operation. So there'll be a collaborative data decision making, which is the same target is going to be observed by multiple sensors from multiple aspect angles. That again leads to a lot of data, which again, it is only AI that has the capability to fuse it all together. And in the end, presented in terms of some confidence value, and that confidence threshold needs to be contextually set by the operator itself. So that's the current paradigm which we foresee and what we are working upon, sir. Over.
Okay, I hope that answers the question. One of the things that even the chief had mentioned was that when it comes to trust of AI systems, as of now, everyone wants a human in the loop. And if you can't have a human in the loop, it's going to be tough. And as you mentioned that too. But eventually, the problem is going to arise when you have autonomous systems, drones which are independent totally, So how will that affect trust?
Sir, may I go ahead on this one?
Yeah, please, but just 1 minute.
Sir, in 1 minute. So what is happening is right now, it is sort of a pre-mission configuration where, the pilot has to decide what all kind of tasks he wants the machine to automatically observe and take. And again, over time, that paradigm will shift to full autonomy. And that will only happen over time as we have more and more models, as we have more and more data. And again, the same spectrum: predictability, dependability, and eventually faith. So, sir, it'll happen over time as tech catches up, and with the pilot spending more and more time with it. It's something equivalent of getting flight hours, sir.
Okay. Thank you, Anurag. Dr. Chandramouli, would you have you recorded the second question, please?
Yes, yeah. So efforts of free space optics is a very active area of research, R&D within the US Department of Defense. And some of the hot topics are multi-beam control of free space optics, optical links, and beam adaptation, and so on and so forth.
Okay. Does that answer the question? All right. We'll due to shortage of time, we'll just go on to the last question. That's Dr. Ranko. Would you take that on, please?
Yeah, so as the person who asked the question already observed, so these are systems that are developed, they're ready to be deployed. Of course, in every application, we need to fine tune neural networks and our deployment strategy for this situation. So I would say on crack detection, it's very similar to something we've already done. So that would be a rather small effort, mostly on this part of the Air Force to provide data set. We could demonstrate detection. Propagation would probably take a little bit longer because that's kind of like a dynamic thing. It has a time component of evolution. It's not just about detection. And then the second part would be to understand what is the IT infrastructure on which this would potentially be deployed. So what are the constraints of deployment? But not much work.
Okay, I think this is an important question because, while Western aircraft have and platforms have, many, components which can be analyzed through computers, etc. The Soviet design and Russian design platforms which we have in the Air Force do not have that capability, for analysis. So you need to give us an answer there sometime, and perhaps you could talk to the guys in the headquarters and because this is a point which I know has been talked about in detail. So we're leaving it to you right now to perhaps go and make a connection at the headquarters and see where you can help them out. Right? Okay.
Absolutely. Thank you.
Thank you very much. Sujit, you can go ahead with letters of appreciation.
Whether can you please flash the certificates of participation, please, for all our 3 participants? These certificates should be emailed to you subsequently, but this is only to tell you that we really recognize the good work that you've done so far. And thank you very much for joining us here.
So that's for Mr. Anurag.
Thank you very much, sir. Thank you very much, sir.
Dr. Chandramouli and Dr. Ranko Sridharbajan. Okay. Right, we end this first session and I'll hand over to you, Sujit, for the second session. Thank you very much. May I request you to give a hand to all these excellent panelists for this first section. Thank you very much, panelists.
Good afternoon once again. It's now my pleasant duty to invite Air Marshal Daljit Singh, the former AOCNC from the Indian Air Force and a distinguished member of SAMDES to lead the second session. Over to you, Air Marshal Daljit Singh, sir.
Thank you, Commander Samandar. Just a sound check. Can you hear me loud and clear? Thank you very much. Greetings, ladies and gentlemen, and welcome to this session 2 of the AI for Air Warriors. During the previous sessions, we have heard experts speak on AI-enabled air operations and the perspective of the Indian Air Force Chief on application of artificial intelligence. Rapid technological developments in computational power, communication networks, and sensor technology have led armed forces all over the world to consider future operational employment philosophy of AI-controlled unmanned systems, either independently or teamed with manned platforms. I will quote few interesting examples, but before I do that, as of today, very large amount of AI systems are embedded in the Indian Air Force. If you look at automatic tracking PGMs, if you look at analysis of change detection in the intelligence systems, if you look at anything, it is always AI enabled. Now we are looking at the degree of AI enabled so that we can move on to almost autonomous systems. Now for this, I'll give you a first example of the US Naval Air Systems Command and Boeing Phantom Works. They are developing a MQ-25A Stingray UAV for autonomous carrier-based operations with the capability of autonomous aerial refueling of other fighters, which is a daunting task, and secondary role of ISR and EW operations. Stingray is also planned to be teamed with E-2D AEW and C aircraft. Last September, like Mr. Anurag mentioned, DARPA has conducted a simulation of 1v1 engagements in which the AI-controlled F-16 fighter won all the 5 engagements against an experienced US Naval Weapons School instructor, like in Indian Air Force, we have TAG D instructor. Last month, the simulation of AI-controlled 2 versus 1 engagement demonstrated the AI capability to successfully engage the adversary in a collaborative manner, avoiding fratricide. Now, as per DARPA, this air combat evaluation program aims to develop trusted, scalable, human-level, AI-driven autonomy by using human-machine collaborative dogfighting as its challenge problem. In next 2 to 3 years, by 2023, the team plans to launch a full-scale model for actual engagement with the AI-enabled aeroplanes. Manned-unmanned teaming concepts are being developed by many countries, and some of them are likely to be demonstrated in near future. In India, Hindustan Aeronautics Limited has an ambitious program called Combat Air Teaming System that will involve teaming the Warrior UAV with Mother Aircraft LCA. New Space Company is actively involved in this program. Royal Air Force has planned to reconfigure the composition of its present Typhoon fighter squadrons from 8 Typhoons to 2 Typhoons with 10 uncrewed Mosquito loyal unmanned wingmen and 100 Elvino swarming UAVs. This change is planned to be achieved by 2030, and the project team is working on it. In this instance, there are very clear, concrete plans on which the industry and the forces are working together. Of course, there are challenges of trust, reliability, performance of AI-controlled operations under contested EM spectrum. Imagine AI-controlled autonomous platforms along with manned systems being controlled by a completely autonomous AI-controlled airspace management system. Trust and reliability would be essential to employ such systems in future. Now, this session will bring out more clarity in these aspects, for which we have invited 4 experienced specialists who would talk on some of these aspects. Each speaker is allotted 10 minutes. After all the speakers have spoken, there will be a 10 minutes available for answering questions raised by the audience. Now, I would like to invite the first speaker, Professor Michael O'Hanlon from Brookings Institute, Washington, USA. His topic is Challenges in the Employment of AI by Air Forces. Over to you, Professor Michael.
Greetings and thank you. It's wonderful to be with good friends today from halfway across the world. And I will try to make a couple of brief points in my opening remarks. And I do this from the point of view, not as a skeptic of AI, but as a skeptic of some of the debate that I believe has been emerging. And I think we have to be careful not to overhype the near-term potential of any one technology. That will be the central thrust of what I'm trying to say this morning, my time. I'm not suggesting that AI be deprioritized in any way. I'm simply suggesting that we need to avoid the sense that we are in a near-term sprint to try to get to some fantastical finish line where getting there first means we win and getting there second means we are vulnerable to defeat. I don't expect anything nearly that simple. My expectation is that most people on this call know more about AI than I do and also are not vulnerable to any such misconceptions. But I do fear the broader debate in the United States and elsewhere can get a little bit hyperventilated, so to speak, on the subject. Let me make my point in two separate ways. The first is simply to note that the term artificial intelligence is now being used very casually and loosely by a lot of people, often in different ways. And this should make us wary about exactly what we're talking about. Specifically, many people, especially generalists and non-technology people, use the term AI essentially to mean advanced computing of any type. Essentially, what they're talking about are, where we stand in the digital age here in the 2020s with the remarkable capabilities that have become available across civilian and military worlds in the last few decades. And since the computer revolution began, depending on how you want to define it, 50 to 60 to 70 years ago, but really accelerated by the end of the 20th century, and then of course picked up into the era of mobile phones and social media and so forth in the 21st. I believe a lot of people use the term AI essentially to describe advanced algorithms, which of course are extraordinarily impressive and can do more today than ever before because computing power is so remarkable and has grown so much. But to my mind, and again, I'm a technology generalist, so some of you may want to refine this point or challenge me, but to my mind, if you have an advanced algorithm, let's say it's a submarine or an unmanned underwater sensor looking for an enemy submarine, and it has several dozen sensors perhaps, and several dozen ways to compute whatever incoming sonar it might receive in its sensors. And every second it is looking at literally hundreds or thousands or tens of thousands of different possibilities and different small computations to figure out whether there is an enemy submarine or some other object of military importance nearby. To me, that is an advanced algorithm. That is not artificial intelligence. I think the term artificial intelligence is more useful when it focuses more narrowly, essentially on machine learning and related areas where the software itself is being built up by the system, where the system is given the ability to develop algorithms based off of data sets that are fed into its various inputs, and therefore that the advanced algorithm does not need to be written in advance by humans. It is developed by the machine as a function of data that is available to it. That, I believe, is, of course, what we mean by machine learning, but to me, it is also the interesting aspect of modern AI. And to the extent that's true, what it means is that AI will be a more specific, focused, and targeted kind of revolution. It will not necessarily be all that encompassing. AI is not something that just started to show up 5 years ago and will blossom in the next 5 years. It needs to be thought of within a broader digital revolution that is lasting decades. And if we ever get to the point of conscious AI and, truly aware machines, of course, that will be revolutionary. But I don't see the near-term or medium-term prospects for that kind of AI being very great. And so I think, again, we need to be a little bit more specific of what kinds of AI capabilities are really becoming available in the foreseeable future and within the time horizon of people building defense technologies. I think it's a much more targeted kind of evolutionary change. It may ultimately look revolutionary in some ways, but I don't think that we need to be breathless about our pursuit of any particular set of technologies to the exclusion of other things. By the way, one warning, and then I'll make my other broad point and finish. But one warning is that if we feel we are in an AI race and we need to get to a certain place before someone else, we may wind up either distorting our defense modernization priorities, putting too much money in certain places, or we may leave ourselves vulnerable to hacking and digital attacks because we have tried so much to build pure capability that we have undervalued the importance of resilience and of protection of our systems. And of course, in the computer age, this is the tradition. This is very much what we've been doing ever since popular electronics became more widely available. We have been building software and proliferating devices, especially in the civilian world, but even in the military world, that are impressive for their new capabilities, but they are also impressive for their new vulnerabilities. And we tend to undervalue, in my opinion, the importance of avoiding or redressing or mitigating those vulnerabilities. So if we think of ourselves as being in an AI race, I worry that we could somehow repeat that pattern. My last main point has to do with an historical perspective. To me, the way we think about artificial intelligence today and the way we talk about it, again, not so much in this group, but in the broader defense community, to me, it evokes memories of the so-called revolution in military affairs debate of the 1990s, which probably began in Russia in the 1980s during Soviet times, and then really picked up here in the United States, to the point where I know many American strategists who believed that we would see revolutionary change across many areas of defense technology. For example, people were talking about an expendable launch vehicle for getting into space that would be 90% less expensive than previous systems. People were talking about ground vehicles that could go 200 kilometers per hour. The US Army War College had presentations with that kind of vision for the year 2010. Well, here we are in the year 2021, and our ground combat vehicles don't go 200 kilometers per hour. They do well if they can go 100 kilometers per hour. Our ships and our airplanes, for the most part, travel with very similar kinds of physics and engineering to what they did before. Their speeds are not radically different. Space launch is becoming less expensive, but the progress is measured in terms of 10 and 20 and 30%, not 90%. And so I remember, and I studied and wrote a book on the prospects for a revolution in military affairs back in the 1990s. And I would say that 2/3 of what we generated in that debate was proven wrong, was proven too optimistic or too forward-leaning and a little too breathless about what kinds of near-term capabilities really were within reach. And that actually affected and contributed to modernization mistakes like the Army's Future Combat Vehicle, which never really had the technology underpinnings to be the centerpiece of Army modernization the way that many folks in the ground forces community had hoped. So with that historical warning, and with my earlier point about the importance of semantic clarity and precision let me sign off there with my presentation. And thank you very much for the opportunity to be part of this important panel today. Over.
Thank you, Professor Michael. In fact, you brought out very relevant points that one has to be realistic in application of artificial intelligence. In fact, as I understand, there are different levels of artificial intelligence. The first one is the reactive artificial intelligence, which you mentioned about algorithms, advanced algorithms, and their application. And the second level comes on to the short memory artificial intelligence, where the machine learning gets involved. And now there could be deep machine learning, and that is where you go on to the higher level of human understanding artificial intelligence. So we have to work and say at what level of artificial intelligence we are in, and what is the block approach to consolidate and move further. And the last point is very valid to say that there is to be no AI race like it was there with the erstwhile Soviets and the Americans to reach the space. And there were risks taken. Here, taking risks with the AI could be catastrophic. So thank you very much for bringing out these issues. And these are the main takeaway points. And now I call upon Dr. Michael Teveniko, CTO, Vega MX USA. And his topic is Gen after next unmanned system. Over to you, Dr. Michael. Screen is yours.
Good afternoon, good morning to everybody out there, and thank you for giving me the opportunity to give a talk on the generation after next unmanned aerial systems. So I started thinking about this and said, oh, this is interesting, and this is something that is very easy to address. And as I started thinking about this talk and the topic, I realized that, you know, it actually isn't. And I think one of the things that we generally do is we think about technology and development as a linear process. So we look back in time and we think about, you know, what happens, how long will it take to do X, Y, and Z. And as I'm going to mention in my talk here, we are actually not in a linear world in terms of discovery and development. We're actually in an exponential world, and that really means that for all of us, including myself, whatever we think about the future, we are essentially going to be wrong, and in many cases, we're going to be underestimating what's going to happen in the future. However, as Michael mentioned just before me, which was great, is that some people think about these things, but they forget about something real, and that is physics, unfortunately, will not change. So, for example, the example with the ground vehicles doing 200 kilometers an hour simply is not possible, or it's extremely hard, right? Because of the physics of ground and what requires. So, what I think the future of drones, well, first of all, I don't think it's no longer about the airframe. I think it's really going to be about the sensors on the platform, the software that runs the platform, and most importantly, I think that the agile development is an absolute key, as Professor from BAE mentioned earlier, is that we really need to get better at doing rapid development of very complex systems. So what's going to happen on the generation after next? Obviously, they're going to be small, smart, and disposable. Designed to missions, precision strike capability, potentially distributed. Our general perception as humans and carbon-based life forms, we think of ourselves as one entity doing one thing. Now, with computer networks and computers in general, that's not necessarily the case. One can very well think about a drone being consisting of multiple parts that are distributed in space. So you can have one entity working as a single entity, but with multiple physical instantiations of itself. A computer can sense the entire EM spectrum. Today, we make distinctions between optical, visual. We talk about infrared, ultraviolet, and radio frequency, right? And we talked about them as radar, and we talked about them as cameras. But all in all, it's about the electromagnetic spectrum and the way we look at them in terms of how we filter them, how we perceive them. The computer is completely different. It really doesn't care what kind of EM wave comes in, as long as it can sense it and create it and convert it to a set of numbers, and then work on it. And we've seen examples of that with what we call multispectral imaging, for example, or hyperspectral sensing. All that it is essentially a different way of chunking up the EM spectrum and then analyzing it, and that brings up a lot of interesting options for our systems. So why is this? Well, if you look at what we're doing today, I'm going to skip this thing. It's basically today, all what we do is essentially traditional weapons development with very complex aircraft, expensive sensors, and these things are extremely expensive to operate. For example, one numbers that people like to throw around on the global hall is up to $11,000 to $15,000 per hour in operating costs. Right? And of course, that's an extreme example of how our development processes are hindering us in development. But what I really wanted to talk about today is what's really been going on, and it really has been going on in essentially from the 1950s and on till today. And Dr. Gordon Moore basically called it the Moore's Law, that basically says, every 18 months to 2 years, the capabilities of a piece of electronic is doubling, right? And I plotted, this is a plot from that I took off the internet until 2020. And it's plotted in a log scale, and you can sort of see where the technology is going. If you look at where the TSMC and the electronics roadmap is going, it basically keeps going up linearly and potentially even faster than exponential growth up till at least 2030. So we look at that, and what it has meant is, if you look at the lower graph here, is that it has looked like it's going relatively slow in the beginning. And then when we change the scale here to look at it in terms of a linear scale, this thing basically goes straight through the roof in terms of capabilities, or capabilities per dollar, or capabilities for any kind of measurement you want to do. And that in turn has really enabled all of these things that is happening today, that with additive manufacturing, automotive autonomy, we talk about massive MIMO technologies for telecom. Our cameras have improved with dynamic range and resolution to the point where they're in fact at least in par with our own vision system, if not better. Okay, and all of these things are really driven by the microelectronics exponential progress. And what that then essentially created itself an exponential feedback loop where essentially as we progress here, it's easier to discover. And as it's easier to discover, this thing basically accelerates. So what that essentially means is that we're on this massive rate. Sometimes, and Michael mentioned it earlier, today, neural networks, machine learning and neural networks is essentially correlation engines, really, really good correlation engines, but it's really not intelligence. However, at some point around 2025, 2030, depending on how we calculate human brain capabilities, we essentially will have computers that are definitely computationally on par with what we can do ourselves as humans. So, and even more importantly is that there's a little step in time here will essentially mean the equivalent of decades of development back in the 80s, 90s, or the 2000s. Because essentially, again, we're doubling every 2 years. So I'll have a couple of examples here, and I'm going to...
Sorry to interrupt, Dr. Michael. We are running out of time. May I request you to shorten this, please?
Exactly. So let me conclude and show what we have in our labs. Something that we have done. Here's something we have in the lab. This is essentially a miniaturized version of an AMRAAM. It's about 50 by 50 by 50 by 100 millimeters in size. It's got a full seeker, multi RF and optical seeker on board, and an optical optionally lethal payload. Full missile capability in a 50 by 100 millimeters scale machine. There's a scalable, flexible, long endurance platform that we worked on. Essentially, it's a sensor package that can be built around an airframe. So we're building the airframe around the sensor package, and by using commercial technologies, we can essentially create a long endurance platform for multi-mission capabilities for essentially a very, very low amount of dollars. There's a full Ki band phased array radar that we're actually working on right now, completely developed by commercial components. It's something we can go to DigiKey and buy today. With a little bit of tweaking, I basically have created myself a radar that is capable, same capability as what we have on the Griffin fighter jet today, for a few $1,000s. And the list can go on and on in terms of ECN capabilities and so on and so forth. So to conclude, I don't think any of us can really say what the drones of the future will be. I think they're going to be flexible, self-direction, very hard to detect, almost disposable and self-sufficient. But the challenges we have here, and Dr. Michael pointed it out, is how do we make them think? How do we make them provably safe, and how do we trust them? And that's really the challenges that we have today in our world. All the other pieces like the flight hardware, the weapon systems, safety, and sensors are essentially well defined by physics. Can't really do much in that space. But the pilot and the mission controller is where we really need to spend our time and money. And with that, I'll thank you for the attention and hand it over to Control again.
Thank you, Dr. Michael, for enlightening us on the emerging technologies for the UAVs. the point which is very, very clear is that the technology is really galloping very fast. As a result, there are parallel competitions, and the throughput is reducing to such an extent that it can be exploited. No doubt, the AI will still have to be implemented in a graduated, in a tested manner, to be safe, to be efficient, and in any case, the operators have the choice to employ these systems initially maybe in a benign environment and then go into the contested environment. So this would be the graduated approach. Thank you very much. Now I invite Mr. Andy Hickel from Microsoft USA. His topic is AI for congested combat airspace management. Over to you, Mr. Andy.
Morning. Let me share my screen here. Excellent. So actually, good afternoon. I wanted to start by thanking the organizers for their gracious invitation to speak with you today. It's really an honor and pleasure to be in such distinguished company. I'm Andy Hickel, and I lead big data and AI investments for defense, intelligence, and government customers on Azure. And I'd like to spend the time this morning to actually talk a little bit about the work we're doing to tailor Microsoft's portfolio to address the operational challenges faced by warfighters, pilots, and analysts. I'm not going to be as technical as I usually am, and not as technical as some of our distinguished colleagues. It's still awfully early here in Seattle. But I wanted to leave you with a sense of what we're trying to do to be able to build and design AI for mission customers' needs. And it's clear to this panel and everyone in this room that AI has certainly received its share of hype. But it's also receiving its share of investment as well. In the US, we're directing agencies across the federal government, from defense to public safety, to invest at least 3% of their total budget in AI systems. And that's a significant chunk, and the trend is only going to go higher. So what's driving this demand? Well, there's no surprise here. It's the convergence of three really well-known trends. First off, it's the emergence of algorithms that are beginning to crack some of the industry's hardest problems. Second, it's the availability of readily accessible compute from the cloud, the hyperscale cloud, all the way out to the edge. And third, and most important to me, is the vast data resources that can be crunched by that compute and fed to these algorithms. And so taken together, these trends have moved the question from when will AI be good enough to try to when will AI deliver the same performance as the men and women I have performing the task today. And at Microsoft, we have a standard, we have a test for that for that second question. And we've worked hard over the last 30 years to achieve what we call human parity on a variety of tasks, ranging from speech transcription to machine translation to computer vision. Oh, but let's not forget the really important stuff. The real important applications like Ms. Pac-Man. A Microsoft research team actually holds the record, an AI team holds the highest record for the highest score ever recorded on the game. I guess I'll keep trying out my, keep trying to put my quarters in the machine to be able to get set my record. But seriously, today, the real challenges lie not in developing a single AI algorithm, but in delivering integrated systems of intelligence that address all of the needs of a particular vertical or industry segment. And so in my group, we're working with partners to build a new kind of verticalized AI, and we call it AI for mission. It's just shorthand for the AI that our analysts, our pilots, and warfighters ultimately need to be successful. And we're executing on the same playbook that Microsoft's followed when building AI for other verticals, such as healthcare, gaming, or retail. And so I'm going to talk a little bit more about what AI for mission ultimately is in a second. But I wanted to start by showing you how fired up I am about some of the things that are possible once you have a verticalized AI platform. Things like rapidly deployable computer vision models that can recognize more than just single static targets, but actually recognize complex behaviors without requiring significant amounts of training data. When the pandemic started last year, our computer vision teams actually took some of the core work that they've done in terms of object detection and tracking and applied it to a variety of pandemic-related use cases, from recognizing social distancing violations to recognizing masks, and the ever important case of recognizing when a car is parked in the parking spot outside curbside pickup, and making sure to identifying who's in the car, what the make, model, number of the car is, and how long they've been waiting there. As a natural language processing person, I'm excited about the work that we've been doing in terms of building large-scale NLP models that can populate tables full of factual information from unstructured text in any language, or generate natural language interactions that are novel, coherent, and trusted. And this is the core of the kinds of next generation interfaces that we're expecting to see, whether that's what's beyond chatbots, ultimately, or what drives the cognitive augmentation that we're really hoping to provide customers with. And ultimately, at the frontier, it's the really the thing we get excited about is simulation, and ultimately filling that simulation up with reinforcement learning based agents that can reason over complex scenarios and provide cognitive augmentation in novel ways, ultimately whether that's through optimization or through some sort of additional kind of recommendation. So what is AI for mission? Well, we ultimately have a set of first principles that we're building from. And these echo themes, this is not necessarily proprietary to Microsoft IP. This is work, this is requirements that we've heard that have come out of our interactions with customers just like you. And ultimately, it's been echoed through themes that we've heard through the sessions this morning. And so, AI for mission ultimately has to be deployable anywhere. We can't. I mean, we love the power and the scale that offered by the hyperscale cloud, but there's the cases where we need to bring AI to the edge. And in a second, we'll talk about the ultimate edge, right? Not just airborne vehicles, but spaceborne vehicles. And so, whether that have to operate on small form factors, on less reduced compute, and still deliver the same kind of value that we'd expect from a web API. We have to have solutions that can actually integrate data silos across domains, right? And so we think a lot about multi-int fusion, especially in the battle space domain, but ultimately we want to make sure that we're not just bringing the data together into a common data lake, but we're actually making sure that we're managing provenance, we're managing security, we're managing access, and we're bringing that knowledge together in a way that can actually truly be interoperable and not just the data doesn't just co-occur with each other. I'll talk a little bit more in a second about how we're getting AI that can actually adapt to emerging threats without actually having to apply armies of data scientists to the problem. But that's just one of the investments that we need to make. Ultimately, we're moving towards AI and machine learning systems that can actually operate autonomously, that can support more complex decision making, and ultimately, as we've heard from other speakers this morning, explain their findings. And the all aim here is ultimately, can we actually simulate real world operations in the detail that warfighters and analysts need to actually kind of prove out and test the efficacy of their plans before they ultimately get down to the field. So we know that AI alone isn't enough. So we're cognizant of connectivity. Connectivity is often key to making AI solutions work in the field. And so we've taken on building a partner ecosystem as part of our AI work. This is known as Azure Orbital. And we've built partnerships with a number of SATCOM providers and 5G network operators, essentially blanket operators and edge devices with reliable comms, even in denied, degraded, or intermittent environments. And we're actually even thinking about what Azure looks like in forward deployed environments, whether it's Azure Stack in a ruggedized device like a backpack, or a modular data center like you see the one on the right here that can actually drop. You can drop it's anywhere you can put a container. You can actually drop in the power of the hyperscale cloud where you need it most. And we're excited with it. One of the things I'll talk about here is we're excited that with AI, one size rarely fits all. And so we're working on new technology that helps break the dependence that many AI and ML systems have on sources of annotated training data, especially for ISR, intelligence, surveillance, and reconnaissance use cases. And so, today when we basically want to break this paradigm, this kind of trap that we've all fallen into. And when you realize your AI algorithms are failing to recognize a novel target, so if you designed your system to be able to recognize the truck on the left, and your adversary starts fielding the truck on the right, you're stuck. You're ultimately left with few choices. You've got to go through the pain of putting eyes on target and basically figure out how to collect more images of that novel target. You've got to bring it back to the cloud or bring it back to your data center and annotate it and label it, and then you have to employ an army of data scientists to go and build models. And that can be dangerous, not just costly, right? Or impossible, right? You may not ever be able to collect sufficient training data, data for the training of those models. And so we're putting together a new paradigm known as data synthetics, which allows you to basically, instead of actually going out and collecting this, a tremendous amount of data, you can actually generate the images that you're looking for, the instances you're looking for, just from a few seed examples, and then ultimately render the data sets in all their beautiful glory with all the kind of environmental conditions or context that you're looking for. And then you can employ that army of data scientists without actually having to do the cost and the pain of actually building those data sets. And what's exciting to me is that you can actually do this at the edge, right? And so if I'm, I'm in the field and I recognize that I'm missing a target, my model's missing a target, I can actually take a few snaps of that target, and ultimately feed it to my synthetics engine running on the edge, be able to generate that data sets in real time. And then, as automated machine learning or meta machine learning actually improves, I can actually go and retrain those models at the edge without having to go back to the cloud, without ever having to go back to an army of data scientists, and ultimately actually field a system that gets more intelligent and smarter without actually having the sunk cost of building training data sets. And so this is an example. This is, we can actually start with a text prompt of something simple as, show me an airport runway at 3 p.m. on a Tuesday, and show me the planes that would actually be likely to expect to see there. And we can actually generate a scene. And this is, you can, if you've got a discerning eye, like many of you do, I can imagine it doesn't pass the sniff test. It's something that can fool you as an actual captured image, but it's good enough to fool the machine learning model and actually improve quality. I'll close by talking a little bit about how important user experience is, especially when it comes to harnessing the power of our human personnel. So we have talked a couple times about simulation and how AI's ultimate home is going to be in simulation, as well as forward deployed devices. But we're really focusing on what can be done today before you actually get to the battle space. And so we're building integrated platforms that allow analysts to be able to build and test those plans in high quality simulated environments. And as we referred to a second ago, kind of tested against.
Sorry to interrupt, Mr. Andrew. Sorry to interrupt. You have 1 more minute to go, please.
Yes, sir. Last slide.
Right. Thank you.
And so, those kind of simulation platforms are, key in part and parcel to our strategy. And so ultimately, if we've talked about, bringing these AI solutions to the cloud. Ultimately, where we're spending a lot of time and effort right now is actually trying to figure out exactly how we can bring AI and ML models down from the cloud and ultimately to edge devices of all different form factors. And so, we're really committed to making sure that we light up any kind of edge device that's out there, even what we refer to as the ultimate edge. And so, what we're referring to as spaceborne vehicles such as satellites and other kinds of spacecraft. And so, whether it's technologies that reduce your dependency on sourcing data, it's technologies that allow you to actually operate and support multiple domain operations, or technologies that allow you to actually bring the goodness that you would ultimately find in the cloud ultimately to wherever you need it to be. That's the kind of problems we're trying to solve in the kind of verticalized platform that we're looking to build at Microsoft. I think that's all the time I've got. So thank you so much for your time and attention.
Thank you, Mr. Andy. In fact, you brought out the points regarding the innovation and employment of AI for processing the data. There was probably an indirect reference to AI for congested combat airspace management. I wish there could be more onto this congested air combat airspace management. To my mind, when we talk of congested airspace management, in any airspace which is contested, every platform would be networked. And the ones which are not networked would be declared as threats or hostile. And therefore, it will be fairly clear that who is friendly and who is foe. And that is what is required for congested airspace management. And of course, the AI would be able to help us in processing this in a much better manner. Thank you very much, Mr. Andy. And now I invite the last speaker, Dr. Paul Fleets. He's the junior team lead, air-launched off-board operations, Air Force Research Lab. And his topic is air-launched UAVs and remote drone carriers. Over to you, Dr. Paul.
Yes, thank you. Can you hear me?
Yes, please, clear.
Okay, and can you see my screen? Doesn't look like it.
Not yet. All right, it's coming on.
Yep. Okay, so good morning from here in Dayton, Ohio, where I'm located at the Air Force Research Laboratory. I'm in the Aerospace Systems Directorate here. And for the next 10 minutes, I'll talk to you a little bit about the program that we have on air-launched unmanned air vehicles. So here I show just a pictorial description of some of the advantages of air-launched UAS. And what we're trying to do in our program is to provide additional capability to the warfighter. And in this picture, you see a host aircraft looking down at a target. But some advantages of using a air-launched UAS or UAV is that you could then have you could look at a different target. You could get closer to the target. You could have a different perspective of the target. You could use it under weather. So if it's cloudy, you could see underneath the clouds. You can help maintain chain of custody. So there's a number of different potential applications of using air-launched UAS. This slide goes well with comments of one of the previous speakers that was talking about agile development. And one of the advantages that we see of air-launched UAS is that these unmanned air vehicles are much cheaper than the host aircraft, and they're much easier to upgrade. So if you need to put on a different sensor, you have a different technology that you want to incorporate, it's much easier to do that on the small UAV than it is to do on the host aircraft. And that's both for the airframe as well as the sensors. So our program started about 6 years ago with a program we called Tactical Offboard Sensing. I'll run this video that shows what air-launched UAVs look like. So in this case, you're going to see a number of surrogate platforms. You'll notice there's some tubes in that picture. The UAV fits into the tube and is launched from the tube. And you'll notice that the UAV, it leaves the aircraft and then goes directly into flight. There's no parachutes or leave behind. And the original requirement to be tube launched was because a number of Air Force platforms already have tubes on them. And so that we could just replace the tube that contained whatever else it had in the past with a tube that contained UAVs. So we did this first demonstration several years ago. Since then, there's been increased interest in air-launched UAVs. And I show this picture from our sister service, the Army, showing a launch of that same UAV from a helicopter. In this case, you can see it going directly into flight, much clearer. In this video, just to show you that we did more than 40 launches in our original program. Since then, the Army has done many more. So this is a very mature technology to provide air-launched UAVs for multiple potential applications. So after we did our initial demonstrations that I showed you, including on a C-130 aircraft, we changed our focus to incorporate it on some other aircraft. And shown here is a picture of a Reaper aircraft. On the left-hand side, you'll see the Reaper launching one UAV. And our initial requirement was for one to provide imagery back to the host aircraft. But in keeping with the theme of this conference on artificial intelligence and autonomy, we're moving to single UAVs operating in coordination with the host aircraft to multiple UAVs working autonomously together with AI algorithms to look for targets and then send information back to the host aircraft. And as the previous speaker mentioned, we talk about decision making on the edge, maybe not quite as far on the edge as he was referring to, but the concept is the same, is that you make the decision happen closest to the target of interest without or minimizing the amount of human interaction or sending the information back to a large computer somewhere else. So one of the things that's required if you want to do air-launched UAV is that you have to have a launch carriage system. I mentioned that some Air Force aircraft have them. You saw in the first video that I showed that there was a tube on that aircraft, but some aircraft don't have tubes. Our launch systems, facilities for the computers and the communication needs that are required to have an air-launched UAS. So we've been developing carriage launch systems. This is an adaptation of an AFRL product called AgilePod. AgilePod is a shell that contains open systems architecture, mechanical and electrical connections. And so we're able to integrate tubes and air-launched UAVs into this and then put in all the electronics that are required to support an air-launched UAV. As I conclude here, I wanted to point out a couple of things that might be interest to this audience. So here in the U.S., we've been working on this program for the last six years or so. But within the last 2 years, we've been working very closely with New Space Research and Technologies. You heard a speaker from them earlier. They are a small business, and we are working with them under a program called a CRADA, Cooperative Research and Development Agreement, and it allows us to share information and technologies with them. That was signed in May of 2019. It goes through December of 2024. For a little over the last year, we've been working very closely with them on a number of technology development that is of mutual interest to both them and us, including some wind tunnel evaluation that's scheduled for this month on different propulsion systems. We've done some analysis of extended range communications, which are important for all of these systems to be able to communicate the information. We heard about resilient comms earlier today, new launch carriage systems, and then autonomy, and for a variety of applications, including humanitarian aid and disaster relief. In addition to that, we've been discussing a proposed project agreement with the DRDO in India. The title of that project would be Air-Launched UAV for Underweather Standoff Imaging and Extended Range Communications. That has been a proposed project agreement for a couple of years now, but we are anticipating that it will be finally signed in May of this year. And it fits under the US DTTI, the Defense Technology and Transition Initiative. So that's a US-India program to promote exchange of collaborative technologies and cooperative research, leading to co-production and co-development. So in this program, we are planning to design a new UAS system from the ground up that meets requirements of both the Indian Air Force and the U.S. Air Force. The agreement's gotten a lot of attention in the press, and I just have one reference there. It will be a 7-year effort, and we're looking forward to getting that started. And so just to conclude, we have a program here, we call it Air-Launched Offboard Operations. The objective is to provide the warfighter with added capability through air-launched UAVs. We demonstrated that. You saw it in the first video on a number of aircraft, including a C-130. We also showed that there's a growing interest in this kind of technology. I showed the Army interest, and that we are collaborating with others, including different groups in India, to advance this technology. And with that, I thank you for your attention.
Thank you very much, Dr. Paul, for a very focused presentation and doing it within the time frame. Thank you very much for that. The point which comes out very clearly is when we talk of concept of air-launched offboard UAVs, firstly, we have to look at the mother aeroplane, the mother aircraft. At what ranges is it going to launch these UAVs? Obviously, it will launch the UAVs at a place where the mother aircraft itself is not vulnerable. And thereafter, what ranges are expected of these UAVs to go into the hostile environment? Mm-hmm. And what would be the capability? To my mind, this is where the users are required to be involved right at the conception stage itself, so that the plans and everything gets crystallized very well. Now, these UAVs could be as a de-ed missions, or they could be for intelligence missions. And their loiter or their capability to revert or the level of autonomy will all depend on what role these UAVs are going to play. Of course, there could be multi-role UAVs also available, but the ranges, the endurances, the timeframes, and the affordability. How cheap are they? Can they be expendable? These are the questions only the user can answer. Therefore, it is important that the user interacts with DRDO and its collaborators to crystallize these plans, and then things move in a much better and in a much better manner. Thank you very much for enlightening us on your capability, and we look forward, and I hope there would be more positivity in interaction through DTTI. And now the session is open for question and answer. I hand over to Commander Samadar.
Good evening, everybody. We have quite a few questions, and at the moment, I think we are also completely constrained by time. So I have noted these questions, and we will be sending these questions out to the speakers and replying back to the persons who have raised these questions. So I request Marshal Daljit Singh to kindly make his concluding remarks, and so that we can move on to the next session. Thank you very much.
Thank you, Commander Samadar. Even though I have been mentioning my concluding remarks, just to consolidate, I feel there is a need for users to be involved at conceptual stage itself, to channelize the development driven by the user concept of operations. As stealth technology is now embedded in all platforms of the Air Forces, AI will also be exploited in all spheres of Air Force employment. But today, the stealth technology is not the silver bullet. So in a matter of years, even AI will not be the silver bullet. Because today, when we say that the man behind the machine makes the difference, maybe after 5 or 10 years, we will say the AI behind the machine is making the difference. Now, what is this quality of AI? Is my AI better than the AI of adversary? How will that be better or not better would depend upon the involvement of the users in making those algorithms and doing the research and doing experimentation, consolidating. Only then can we have rich dividends on AI application. And second part, as far as trust is concerned, it is a kind of a graduated and gradual manner. Today, the pilots are flying electrical flight control system aeroplanes where all the inputs are controlled by the computers and the pilots are trusting them. Now, this level of trust will build initially by operating these AI systems in a benign environment where there is supervision by the pilots or by the machine or by the humans, and later on giving them more autonomy and more challenging missions. So it will be an evolving process. It will take years, but a serious involvement of the users and the industry is important to move in the right direction. I thank you very much, all the speakers who have been giving their views. And now I hand over to Commander Samadar.
Thank you very much, sir. It's now our pleasure to share the certificate of participation of our very distinguished panelists on behalf of Air Marshal Daljit Singh, our session chair for this session. Our first certificate goes to Professor Michael Alon. Mike, thank you very much. Dr. Michael, yes. Thank you very much for being with us today. And Dr. Paul, thank you very much for being with us. Andy, thank you very much for being with us. And we now move on to the next session. Please give a round of applause to our panelists and to our chairman for doing this wonderful session in really bringing us up to speed on time. Thank you very much, Chairman, sir, for today's contribution to this e-Sim. Thank you, sir.
Thank you.
It's now my pleasant duty to lead us on to the third session, and we are extremely privileged to have Air Marshal B.R. Krishna here, who is the Director General Air Operations, with great amount of experience and widespread experience across weapons projects and plans. And I now request Air Marshal Krishna to kindly take over the proceedings and run us through session 3, which is a very interesting one on all domain warfare. Air Marshal Krishna, sir.
Thank you, sir. Firstly, it's very interesting to be part of this seminar and taking part where I would put it that we are globally on the same platform this evening. In fact, this reminds me of a cricket match, as we call it in India, day and night match. As in India, we are seeing the sunset, we are seeing the sunrise in US. That's where we are today. And thanks to this e-Symposium and VC platform, that we are seeing each other live. And that's the most interesting part of it. And you see one gentleman with the Capitol Hill behind. So what is interesting is that thanks to COVID, the times have changed and we are able to interact so freely, even in a medium erstwhile we would stay away from. This AI symposium has been an eye-opener. I see the galaxy of speakers from this morning, from this afternoon, who have been participating in this. And the last two sessions have been very interesting. And we have moved from AI modeling to algorithms and applications. And the second session, of course, was the previous one, which was on unmanned systems. The final technical session is, I find it very interesting to air operations, is the all-domain warfare. And this is, I would tell the audience to have a cup of tea or coffee, be awake for the next 45 minutes to 1 hour. And our speakers are one of the best speakers who are there, which I feel across the globe. And without further ado, I would like to introduce our first speaker. Our first speaker is General James Boss, and he is a veteran who has seen vast combat experience in 4 wars. And he's also got extensive experience in cyber operations. And he is going to talk to us about combat cloud and all domain warfare. So over to the first speaker.
Good morning, sir. Well, at least good morning here from the Gulf Coast of Mississippi near New Orleans. I think you don't necessarily share my conception of what time zone it is. I really appreciate that kind introduction. I have to admit that this is the only the first time I've interacted with folks from the Indian Air Force since I was on active duty. I can always remember the first time I was Chief of Air Combat Command Intelligence, and I believe this was 2006, which was the first time we invited our Indian friends to fight in Red Flag. And as Chief of Intelligence, you rarely get phone calls about Red Flag unless something has horrifically gone wrong. And something had horrifically gone wrong. The Indian Air Force had showed up and pretty much wiped the floor with us there. So somehow that was my fault for not briefing them on the Indian Air Force being that good. So hopefully we invited you back to Red Flag. I know that occasionally we disinvite people that are a little too good, but I hope we've stopped that tradition since then. But listen, what I'm going to give you a talk about right now is all domain warfare. And I'm a retired airman. I'm going to give you the U.S. Air Force version of all domain warfare. And really, in the Air Force and now in the Joint Forces, because they've finally agreed with us as of December of 20, it starts with 2 programs. One is the Joint All-Domain C2, or JAD-C2. I wish we could think of a better nickname for it than that. And then the other one is the Air Battle Management System. I'm going to start with the Air Battle Management System first, because that's the one that really kind of threw us a curveball and caused us the most confusion. So Air Battle Management System was started in, I believe it's 2019, when we had a new commander of Air Combat Command that came in, and in the U.S. Air Force, Air Combat Command roughly balances the budget for the mission areas that it has. And one of the mission areas that it has is Global Integrated ISR. General Holmes came in, took a look at what it was going to take to recapitalize the JSTARS aircraft, our ground moving target indicator aircraft, and decided that we were going to forego putting the current plan, which was to put the radar onto a business jet and go with something else, which he coined the Air Battle Management System, which we weren't exactly sure what it was at the time. We're not exactly sure what it is now, but the idea is to come up with a system of systems that is target-centric but platform-neutral, that would allow us to use a variety of platforms to accomplish the mission then of JSTARS, but then we've since added that on to just about any other intelligence, surveillance, or reconnaissance sensor that the U.S. Air Force has. Parallel with that, We had the JADC2 effort coming up, which again is another data-centric, platform-neutral way of doing combat. The problem that we've run into with it is, unlike previous iterations of very major command and control changes in the U.S. Air Force, we didn't marry this one up with years of doctrine thought. And I'll compare and contrast this with the Air Force that I joined in the early 80s, which was just beginning to implement air-land battle concept doctrine, which was something that the U.S. Army originally came up with in the ashes of Vietnam, a war that the U.S. Army knew that it had lost and had to get better from, and kind of drug the Air Force kicking and screaming into it, because the Air Force's version was that we sort of won Vietnam. Beautiful concept, beautiful doctrine, beautiful example of two services working together, and it's really spawned most of the major weapon systems that we use to this day. Basically, the idea was the doctrine was the Army was going to hold them in the nose, stop that initial first echelon of attack by the Soviets, because it was aimed at the Soviets, and the Air Force was going to come behind, knock out their infrastructure, take out that joint second echelon. But it spawned a whole bunch of concepts that we hadn't had before. The idea that we had to look down, shoot down over a vast area to keep enemy forces off of our side and allow us to operate offensively, spawned AWACS, spawned Link 16, tactical data links, which we now use as Link 16, pure air-to-air fighters like the F-15, multiple rocket launch systems and all that. We haven't done that yet, and hopefully we will do that with ABMS and JADC2, because I'm going to argue that you can't come up with an idea like Combat Cloud or ABMS or JADC2 or Sensor Grid that we'll talk about in just a second, separated from what you're going to do with doctrine, how you plan to fight. And true to form, listen to what U.S. Air Force leaders say about ABMS and JADC2. They will inevitably devolve into some type of Silicon Valley example. Well, JADC2 is like Waze, so Waze, you don't worry about all the sources of information that Waze uses to figure out how to get you home. It just gets you home unless you know where the traffic jams, or it's like Uber. You don't worry about where all of the cars are. You just ask for them and they magically show up. My counter to that is, number one, those are civilian examples, and you kind of have to struggle to figure out how they apply to air warfare. And then number two, Waze is a great system if you have the software, if you have a defined operating system. In this case, we've got two, iOS and Android. If you've got this fantastic handheld device that we now call the smartphone to do this, if it's supported by billions, if not trillions of dollars worth of cell phone technology, if it's supported by trillions of dollars worth of, I guess we're up to 4 global navigation systems. And if you got all that, yes, it will work in downtown DC. Compare and contrast that in a B-21 bomber on your way to a target in, say, Beijing, and not that we're planning to bomb Beijing, and you got nothing. You can't use those cell phones. You probably can't use GPS. How does it work then? I think that we're coming around to the notion that we really should have thought through all that to begin with. The problem that we have in the military, all militaries, I'm sure it's a problem in the Indian military as well, is that it's very difficult for us to set requirements for cutting edge technology. Number one, because our requirements process is so stilted, and number two, because technology changes so much. And we've definitely got that problem in spades with ABMS and JADC2. Compounding that is the fact that I've come up before that C2 isn't, that the doctrine to support this new C2 change isn't there. The big problem is the business model that we seem to be latching onto for a lot of these things, for Combat Cloud and the Sensor Grid and JADC2 and ABMS, is largely a Silicon Valley business model, which I've got nothing against. It's great. It's very entrepreneurial. It's yielded some of the most fantastic techs that we have. But again, does it really apply to the military model? Silicon Valley is great for Apple and the iPhones and all that, because they're going to make hundreds of millions of them. It's great for Waze because they've got this established app store, and they can hang that up there, and they're going to make, you know, tens of millions of Waze things, so they can afford to charge a few pennies for that. How's it going to work when you're only going to make 24 apps for something specific that the Air Force is doing? How is it going to work when you've got to create not just a worldwide, you know, cell phone or communication network, but it's got to be one that will survive in any electromagnetic environment. It's got to be one that will be completely and utterly secure, because all my time in NSA has taught me one thing. It's not so much the speed of computing, it's the security of computing that matters. And how are you going to do this in a timely manner so that you can actually acquire something? Those are all questions that are still up. Those are questions that we're answering. But the basic concept behind Combat Cloud and JADC2 and ABMS, that the C2 problem needs to be data centric and platform neutral, is brilliant. However, the devil is definitely in the details in the acquisition of this program. And I believe I am out of time. If somebody is looking at me, will we take questions, or is that it?
The questions are the end of the session. You can proceed. You have another 2 minutes.
Oh, I have another 2 minutes. Okay, great. Well, I'll keep going on top of that. So the devil is in the detail on this. But the thing that the U.S. Air Force and now the Joint Force is really moving out on is we've kind of shifted from doing ABMS in spirals, where we would kind of come up and just say, hey, industry, bring us your ideas, and we'll look at them and we'll decide if we're going to take them, which we did on our last ABMS spiral, which was back in December. You know, which is great if you want to get innovation, but on the one hand, we had everything from robot dogs to brand new stealth data links out there. It really wasn't focused on us. We've now, since in the Air Force, turned over acquisition for Air Battle Management System to the Rapid Capabilities Office, which if you watch one acquisition authority in the whole DoD, watch what the Air Force Rapid Capabilities Office is doing, because these are the folks that can move very, very quickly. They've got enhanced acquisition authority. They generally work in the gray or black world, and they're the folks that are bringing us the B-21 Raider in the space of maybe 1/5 of the time it would normally take to do something. So Mr. Randy Walden, a good friend of mine and a great American, is running that option now. JADC2 has now been taken over very willingly by the Joint Staff with input from all the services, but particularly the Air Force and the Army. That's going really well. The problem what we're running into in that is kind of going back to the same problem I mentioned before of contrasting Silicon Valley acquisition and the way they run things and the way the military run things. You can't really compare and contrast how Silicon Valley created a modern email system, because that was done for a very specific purpose with a lot of standards, with how you're going to have to tame all of the data that the DoD needs to run this, because the DoD doesn't really control all of the data that it needs to run. So compare and contrast what it takes to get me from point A to point B with my iPhone. I rely on SMTP standards for my email. There's an SMS standards for my text. It's been there for decades. The Waze makes up its own standards as to what it's going to do. It can do that because it's a private company. It's all processed on my iPhone via iOS, which is very tightly controlled by Apple. And it's really not that much information that I need to go from point A to point B, and it's all relatively tightly controlled by some very big companies. Compare and contrast that, you put me in my B-21 and I've got to go from Elmendorf Air Force Base to a target deep in, pick your least favorite country in the Pacific, and look at the amount of data that I've got to go to do that, and where that data comes from. I got to get my weather comes from, which is sort of from the Air Force, mainly a lot from the Navy, is sort of controlled in standards by the by NOAA. I've got to do mission planning. I've got to get ELINT, electronic intelligence. That's controlled by the National Security Agency, which sort of does, sort of doesn't work for the Department of Defense. I've got to work on a variety of proprietary interfaces on my mission planning for the B-21 to get all that information in. And oh, by the way, there's nobody really in charge of all that data. There's nobody really in charge of a single operating system, and there's nobody really in charge of the communication system to do that. So I think we got a lot more work to do with this, to do on this concept, but I think that we've got quite a ways to do that before we'll have something that's ready to take for combat. So I think that was 2 minutes, was it not, sir?
Yes, thank you, General James.
All right.
And it was interesting to share your thoughts on the battle management systems and the JADC2. More details we'll cover a little later. I will go on to the next speaker. Next speaker is from Germany, Dr. Felix Govares. Please pardon me for the pronunciation. And he's a man with data fusion. He's going to talk us about multi-data fusion, especially the warfare where we have a host of sensors which are there, and how do we actually fuse the data? And especially imagine the platform being dynamic. So I think we have some solutions from Dr. Felix. Over to Dr. Felix.
Thank you very much for the kind introduction, and thank you that I may participate here. I also thank the previous speakers. These were all important aspects you have brought into. Many of the methodologies and technologies you have named are also here in Germany play a great role. And as Fraunhofer FKE is part of the French-German project for the next generation fighter, the Future Combat Air System, FCAS. Since more than 10 years, I want to also bring a little perspective of this project and of our experience in this project into the discussion, maybe a little bit from an engineering perspective, but of course, without going into any details. I have two most important points to make, and the first one is sensor data fusion is the basis for information superiority. So I want to thank also Professor Michael for indicating that it is critical to overhype artificial intelligence and that we are not in a race. But even though he asked for being challenged, and I would say artificial intelligence is more than deep learning. And I think this is a very important point also when we want to go to achieve these goals which we are setting, which are visible at the horizon, but we still need an iterative progress to get there. And here I want to highlight that the classical data fusion based on statistical methods and a real interpretation of data still play an important role nowadays and also in the future. Of course, deep learning is to be integrated in those systems seamlessly, and they play an important role when it comes to perception, classification, or strategic prediction, and many others, of course. But still, you need an interpretation of hypotheses, of histories for data in order to get a real conceptual basis for situational awareness. And in the FCAS project, we were talking a lot about how to fuse the information from multiple sensors so that we can get the best situational awareness. And when you bring it all down, besides integrating deep learning methods and other new technologies, it is still very important and a lot of effort is made to model those information we can gain. So the information might be from a sensor, and the information might also be from other sources, context data, maps, weather, and so on, and also from the previous history. And I want to highlight here that the modeling of the sensor and from the modeling of the information is a very important point when you want to have a consistent and reliable situational awareness, because that essentially makes the big difference between a good and robust algorithm and a bad one. And we have seen that it is extremely important, for instance, to have state-dependent probability of detection and state-dependent clutter maps to be integrated in the systems. This brings a lot of benefit for also having a good, reliable result in challenging situations. And then in the FCAS system, we are also speaking about a system of systems. So therefore, track-to-track fusion capabilities is very important so that we have a combination of data and a pre-processing of data on several levels. So each node in such a system might act as a fusion center, but itself might be a sensor. So you have different hierarchies of data fusion, and you have hierarchical topology for the information flow, which has to be tracked on. And if you keep it that flexible, it suits well in a system of systems where you don't know what happens with your data, what happened previously with the data, but it can always be fused consistently and can also be shared with your partners without the danger of data incest. And of course, context data is an important role which marks the next generation fusion engines, so that you don't only fuse the sensor data, but also match it with background information, with maps, and with weather, whatever it be. So you have to formalize those context information, model it again in a precise manner, and integrate it into the fusion systems in order to get better tracks and more reliable systems. But we have also been integrating deep learning methods for data fusion. That is, for instance, for prediction methods. So we can use, if we have data sets on targets motion, we can use those data sets to predict the motion, and also the hypotheses for data motion can be taken from those deep learning methods. We have also integrated in electronic warfare domain. So also here, a classification and also prediction, what happens in a highly agile spectrum. Here also deep learning is very powerful, and I think is a quite emerging field of research actually. The second part is here on the resource management. So the resource management is based on the situational awareness we have gained from the sensor data fusion part. And we can act now in the real world with agents, with actors, with sensors. So acting of sensors in the sense that we can schedule, for instance, sensor parameters to optimally achieve the best amount of information in the future. And to this end, we need a good situational awareness. So again, here, the sensor data fusion is the basis, and it's very important. If you have a good situational awareness from the sensors, you can act optimally and also look into the future with partially observable Markov decision processes, and then decide stochastically what is the best action to take. And this can be applied to a different field, number of fields. So we use it for path planning, so considering the position of the platform as a resource, and optimally choose the path for future actions. Then I also indicated that we're looking a lot of electronic warfare, both from the perception perspective, so to categorize potential emitters and to see what they are doing next, and also to use it for a cognitive utilization of the radio frequency spectrum. Then another task for resource management in unmanned teaming is, for instance, a weapon target assignment. So if you have, future combat systems have to be able to cope with potential saturation by swarms, and this is, I think, a great danger, and it is still unsolved. And so here in coping with swarms, we need an effective way to fight swarms, and here weapon target assignment is a crucial key in order to effectively employ the resources we have by limiting the costs for employing those weapons. And this can be solved also with those stochastic decision processes by using the current information we got from our sensors, and by modeling the costs and also the gain we have from our resources, such as weapons, and then stochastically calculate the optimal utility. And last but not least, I also want to highlight that, of course, swarming is also one of the most important topics, which has not been so much discussed here today, but I think it is one of the most important aspects of future combat air systems. So we have systems of systems which have remote carriers, which can act autonomously without an air pilot, but that's not swarming yet. So swarming is really the control of a large number of unmanned aerial systems, which are still under control of pilot, but not, of course, in a direct manner, but in a higher level manner. And for such multi-agent collaboration, resource management is also the key. So we need a clear task assignment, we need a path assignment, we need a good collaboration in the sense of the overall overarching goal, which is to be achieved. And therefore we need a good collaboration. And all this, and this is maybe the most challenging part of it, we need all this with the least amount of communication possible. So we have also seen in the past conflicts of nations that communication is more and more critical because it can be spotted so easily with 24/7 present sensors. So you need to be able to do as much as possible on the edge without big data bandwidth links, in particular when it comes to sites where persons are present and which can easily be spotted when they are starting to communicate. So all this is very challenging, but we have the tools at hand. So as we know from research, there are good solutions. There is put a lot of effort in terms of money and manpower into the research field of artificial intelligence, data fusion, multi-agent robotics, and so on. So the solutions are there, but it's still a huge engineering task to put all these puzzle pieces together and to get a reliable overall system which where all those parts play well together. We always were advertising the data fusion centric approach in the FCAS project, and I think this was a very good way to go, since this is quite of the basis for autonomous acting and for decision support for the pilot. And last but not least, I want to also emphasize that this has more and more become a multi-domain aspect here in Germany. So the FCAS project went ahead and set different aspects and was the first of the German forces to say, yes, we need a combat cloud, we need autonomy, we need remote carriers, we still need control of the pilot, of course, but we need a lot of automation. And now other forces are looking towards the results we have gained here in this project. And I think this is a very interesting time because it's coming bigger and more efforts is put in this. And I think the success of the project shows that we are on a good path here. And I'm very happy to hear that the other nations here are going in a similar direction. And I'm happy for exchange if you're interested. So that already brings me to the end. I just wanted to highlight the importance of data fusion, the importance of resource management in a stochastic way, not to forget the, so to say, the old approaches to interpret data, not only throw everything into a neural network and say that's the result. I think that's not the golden standard in the future. The same holds actually for autonomous cars, but that's maybe a different topic. Okay, then yes, thanks for the attention, and I'm happy to answer questions after this session.
Thank you, Dr. Felix, for sharing your experiences on AI and data fusion and the importance of data fusion in the future programs which are on the anvil. And I'll go on to the next speaker. We have Dr. Mary Cummins from the US Navy. She's a retired military pilot from the Navy, and she also happens to be the one of the first few Navy female fighter pilots in the US Navy. And we are interesting to hear from you about the manned, unmanned experiences on the teaming part of it and the interface which we can have between humans and unmanned vehicles. So I request Dr. Mary Cummins to take over.
Thank you. Can you hear me okay?
We're hearing you strength 5.
Great. Thank you for that lovely introduction. I didn't actually retire from the Navy. I just eventually, I just got out after 10 years, but I really am appreciative of all the experiences that I had in the Navy because they were directly informative for I have now an academic, and it certainly motivates me. And indeed, the Navy is funding the research that I'm going to tell you about today. So we're going to talk about manned-unmanned teaming, some experiences and lessons learned that I have had through all the years I've been doing human drone unmanned aerial vehicle experiences. But given what Felix just told you, I'm going to go a little bit off script and I want to kind of pile on a little bit and I'm going to show you some pictures of something that I think you need to know about why humans are still so important, especially in the age of autonomy and growing autonomous systems. So what you heard is true. I have landed aircraft on aircraft carriers. That indeed, it was my experience around aircraft carriers and seeing advanced automation. I flew an older aircraft called an A4 Echo, which has no automation in it. And then I went to the F-18 Hornet, which has a lot of automation. And as a consequence, when I flew Hornets, I saw about one person on average a month die for the 3 years that I flew Hornets. So that's about 36 people, and that's a lot of people dying, and they all died because of problems with the man-machine interaction. And so that really motivated me to look around and say, why aren't we doing this better? And so that's what drove me to go back into school. I got my PhD. I was at MIT for 10 years. I got sick of the winters. Then I moved to Duke, and now I've been here 8 years. And my lab is called the Humans and Autonomy Laboratory. And so we really do focus on how should you design systems to complement human strengths and abilities, as well as let humans make sure that they're filling the gaps for autonomy, particularly AI. And so a lot of the research I've been doing lately looks at how should we design AI in systems. Today, I'm going to really focus on unmanned aerial vehicles. Other people call them drones, but there are obviously a lot of military applications. We see this is a very popular use right now, the small handheld. You can see these two devices. These controllers can look like something like an Xbox controller that are handheld, although you can get some laptop-based controllers. These are the small versions that we see. They can go all the way up to really, there's no limit in the size of a drone. Most commercial aircraft are actually drones themselves. Pilots only interact with the systems for about 3 minutes out of every flight. So there is no limit to the size, although the control systems can become more complex, and certainly the tactics and procedures and how you deal with that need to become more complex. So I want to tell you how I think about, when I think about systems, when I look at systems, how do I know where you should put the balance between the human and the autonomy inside some kind of system? And I'm going to talk about aircraft, drones specifically right now, but this could apply to cars, surgical robots, really anywhere where you think you want a robotic system. And it's called the SRKE framework. This is skills, rules, knowledge, and expertise. And so on the very lower left, you get skill-based reasoning. And what does that mean? It means that a person is trained to keep the aircraft in balanced, stable flight. So the pilot can make sure that the aircraft stays on altitude, on the right heading, and can successfully and safely take off and land. And once a pilot learns how to do those skills, then the pilot frees up cognitive resources to then do what we call rule-based reasoning. And in this picture I'm showing you, this is a very typical waypoint controlled map where pilots lay waypoints and then they direct the drones, and the autonomy does a great job of following directions. If it can figure out how to go from one point to another. You just heard Felix talk about path planning, and certainly that is a very, very traditional, I would say very mature technology in unmanned aerial vehicles. But what you're seeing is you're starting to go up this curve that's getting fatter, the arrow's getting fatter. And what happens is you need higher levels of reasoning as you experience more uncertainty in the world. You get up to knowledge-based reasoning, and this is where we have a lot of uncertainty, and it's something we call judgment under uncertainty. You have to make judgments about what to do and how to fly the drone. You don't have exact procedures that you can follow. You don't have a button that you can push to make it happen in the way that you think it should happen. And so up here I show an air rescue of somebody who's drowning. A drone is going to drop the life-preserving device. And so this is tricky, right? You need to get it close enough to make sure that the person can get it, but there's generally wind and other issues that you have to worry about. And so you need some skills, but you also need to know knowledge. You need to have anticipation of winds, what's going on with other first responders in the area. And then when you get to maximum uncertainty, and that would be what would happen. So for example, if all of a sudden some gale force came out of nowhere and pushed the drone way off course, then what to do, how to avoid houses, how to avoid people and doing damage with it. And so those pilots that experience the highest levels of uncertainty, those are the greatest experts. In America, we would say Chesley Sullenberger, who is the pilot of the Airbus that went down in the Hudson River, and everybody got, the famous picture of everybody standing on the wing. This is maximum uncertainty, right? And hopefully what automation does in this sense for UAVs is it helps drive down the uncertainty. Hopefully, that's assuming that the autonomy can fill the gap. And I'm going to show you a picture next that shows you why that's a problem. So for now, automation / autonomy really sits more at the left. And what is the difference between those two? It's really the degrees of probabilistic reasoning that the machine has to do. If a machine can reason with high degrees of certainty, meaning probabilistic reasoning is very low, that's automation. The thermostat in your house is automation. You turn it to 72, it goes to 72. It's a closed feedback loop. Autonomy happens more for open loop systems where we don't have a lot of feedback, or the feedback is not correct, or it can be very wrong, right? And unfortunately, warfare is on the high uncertainty. The feedback, there are some parts of warfare, flying planes, for example, that's low uncertainty. We've got tight feedback loops. But if we have more open loop control, which is what is happening in warfare, then that's really where we have autonomy, where we have a lot of probabilistic reasoning. And we get into trouble. I've been on a Don Quixote-esque adventure across America, especially with COVID, so I've been doing it virtually, to educate people on just how bad anything with a neural net can be if you need to reason with relatively tight confidence intervals. So let me give you an example. So you heard Felix say that there are some issues with driverless cars. So I thought, oh, this would be a good time to show you what those issues are, since most people haven't seen this. So I've been working with Toyota Research Institute. They're the ones that gave me these pictures. So they had a driverless car running around Cambridge, Massachusetts, and a car got to this intersection and it froze, and they couldn't figure out why it wouldn't move. It just wouldn't do anything, and the human had to take over. And then later they got it back to the laboratory and they pulled the black box, as it were. And so they ran the annotation software, and I'm going to show you then what the car saw. So you see a truck, here's what the car saw. All right, let's go back and look at it one more time. Here's what you see with human eyes, and here's what the car sees with computer vision and a lot of convolutional neural nets, which are what make up deep learning. The car sees 2 trucks, a bus, a huge person, 4 poles, and other traffic sign, fence. Okay, we go back and look at it one more time. And so what's happening is it sees a picture as a person. It sees, because of the 4 poles, it interpreted this as a fence. It sees this as a sign. In your brain stitched all this together in less than a microsecond, and you knew instantly this was a truck. Unfortunately, autonomy cannot do this. Deep learning cannot do this. Now, this is in transportation, and if you want to know why John Krafik, the CEO of Waymo, just quit, this is why he quit, because he can't fix this. And if he can't fix it, if Waymo and Google can't fix problems that we have with deep learning, I'll tell you who definitely cannot fix it. Raytheon cannot fix it. Lockheed Martin cannot fix it. Boeing cannot fix it when it comes to military systems. Dun, dun, dun. I just want to pound my fist on the table and tell you, deep learning, neural nets, machine learning, it's a siren on the shore that's trying to call you in and sing you in. I'm not saying we should never use these technologies. There are really good applications for these kinds of machine learning based technologies. But if you have anything that you need to, any task that requires any kind of vision component, and I mean targeting, I mean, that's what I used to do in the military. I know what it means to have to look for a target. I know what the consequences are of dropping a bomb. The US military, nor any military in the world, should be having any kind of targeting system that relies exclusively on machine learning without a human in the loop. And so this is my tirade to tell you, this picture here is why we need more manned-unmanned teaming. We have got to bring the human and the machine together, because humans can obviously, you knew what this was instantly. The machine does not know what it is. And so if we bring the 2 together, then we have a nice complementary relationship. Okay, let me get off that bandwagon and tell you about this interesting study that we did for the Office of Naval Research to look at who's better, Air Force pilots or Army pilots, which is kind of funny because the Navy paid for this story with this research, and they don't have any what we would call program of record unmanned aerial vehicles. So they're thinking about it, right? The Navy wants to have formalized programs in UAVs, but they're not sure who's doing the training correctly. Is it the Army, who lets enlisted men and women control drones with about 6 months of training? They're not pilots first. They don't know how to fly before they start learning how to control a drone. Now compare that to the Air Force, where they send most of their drone pilots to 2 years of flight training. They become pilots just like I used to do. And then after 2 years of flight training, then they send them to drone school, and then they're all officers. So there's a big difference in the way that the 2 militaries are training the people. The Army feels like, that curve that I showed you, the Army feels like we could basically skip a lot of the skill-based training and plug them in right at the rule-based training. The Air Force says, no, we have to do the whole curve because that makes you a better pilot. So we wanted to conduct a formal experiment to look at that. So what we did is we built a lab space, and I've got tons of pictures and movies and papers on my website at Duke that you can go and read a lot more about it. But we basically created an indoor flight arena, and we had the same kind of setup where we had people learn to manually fly drones. It took them a lot longer. And you can kind of see here what the controls look like. So they're virtual instantiations of the Xbox controller, where you just kind of use your thumbs. I have a 13-year-old, she's amazing at it, who can fly drones with their thumbs. This is more like the Air Force, how the Air Force would do it. And this is more how the Army does it. It's kind of like touch, it lays those waypoints. Touch here if you want the drone to go here, and the drone goes there, and you can plan a route. And then the whole goal was to maneuver the drone to a place where we call this the Fukushima experiment, where the whole inside of the lab was built to look like a bombed out cavernous space like a nuclear reactor, and you're trying to fly a drone through this big space to get to a panel so that you could read some buttons, so that you can take the information back out to whoever the commanders are that need it. So obviously, even though it was really under this first person view drone, obviously a lot of military implications. So what did we find out in the study, which I would encourage you to go read about? So what we found out is, you know what?
Dr. Kemans may kindly intervene. We are running out of time. And if you can
Okay, this is my last slide.
Thank you.
So one thing we found was that in the SC is basically the Army's way. So the pink is the Army way, and the blue is the Air Force way. And it turns out everybody gets to generally the same region of performance. What we found out is if you give people all that extra training with manual control, like old pilots, they get better performance, but they can also get worse performance. And the other thing that we found out is the Army people, they're not getting as much training, but they're getting very specific training. So they end up having a much more narrow band of capability. And so, this really will depend. So as is in life, there's no one right answer. Maybe this group, maybe you want people that are very predictable, but if you really, really, really need your top performers, then maybe doing it the Air Force way and training them at the skill level instead of inserting them at the rule level, maybe that's the right way to do it. All right, I yield the floor.
Thanks a lot for interesting insights, especially with the comparison of the Air Force and the Army. It interests me personally. And we go on to the next speaker. And this is the final speaker of the session 3. It is Dr. Rao Ramanan. And we welcome you for your talk. And he's going to talk to us on space-based surveillance systems. He's an expert in SAR imagery, synthetic aperture radar, in X-band and resolutions up down to 50 centimeters. A very relevant topic. And he's going to talk to us about some case studies. And over to Dr. Rao.
Thank you very much. Are you able to hear me?
Yeah, maybe you can be a little louder. Your decibel levels are a little low.
Okay. Normally I speak very loud, so I was trying to speak lower. Thank you. Thank you, Air Marshal Krishna, and thanks for giving me this opportunity of presenting space-based surveillance systems for strategic situational awareness. I will just straight jump into the briefing here. Capella Space, where I work, is founded in 2016. We launch our own satellites with synthetic aperture radar. There are 3 satellites. We are the first and only American commercial company with 3 satellites flying currently, and 2 more are going in Q2, 2 more are going in Q3. We delivered almost 30 TB of data since January 1st. And we are working on Capella 9 and 17 satellites for next year launch. You can see here a very interesting video from our satellite when the antenna is deployed with the Earth behind it flying fast. So having said that, the satellites are small satellites. They are 110 kilos class. Normally SAR satellites are 1500 are big. So the satellites are highly agile, can take right to left imaging, and they will be able to downlink the data to the nearest ground station, and then on the data goes onto the cloud. So the agility helps us to image, and also we get about 10 minutes of imaging per revolution of the satellite around the Earth. And our radar is very interestingly designed by our own engineers, and we use 500 megahertz of bandwidth. This gives up to 30 centimeters slant plane range resolution. Our product spotlight, which is 50 centimeter with 9 looks, sliding spotlight 1 meter with 5 looks, strip map with 1.2 meter with single look. I will explain the advantage of 9 looks here. Single look images normally will have speckle like this, which will make it difficult to interpret the images. Multi-look 9 looks we use remove the speckle and make it more contrasting. So the images are much easier to interpret, especially for machine learning. You will be able to pick up the signatures of the different aircrafts or vessels or objects. So we offer both single look and multi-look images with different resolutions. These are designed for combatant commands with persistent imaging missions, rapid high priority tasking by customer, low latency, and high standards of data security confidentiality of US government. These are our current customers with whom already we are working: the National Reconnaissance Office, National Geospatial Agency, US Air Force, and DIU and Navy. We are already working on several projects with them. I will give you some examples of some images, how they look in our synthetic aperture radar high resolution imagery. You can see here is a Marj Rihal Air Base in Syria, where the interpretation has been done by our analysts. You can see here likely artillery support and SAM staging area, hangars with possible 77 Squadron MiG-23s, and underground artillery bunker storages, and artillery support and SAM staging. And here are 5 possible 767s and 8 possible 767s. So the situation there on the ground, what type of facilities are there, what type of aircrafts are there, are interpreted very quickly by analysts. And here is another example of Al Udeid Air Base in Qatar. You can see here actually Boeing C-17s, 11 of them, and you can also see here the Qatar Air Force rotary wings helicopters here. And here is another example of Boneyard at Davis Monthan Air Base in Tucson, Arizona. And there are several aircrafts which are not being used, hundreds of aircrafts. When we image them and get the signatures of that, they go into the machine learning and the AI for automated identification of the aircrafts. And here is the interesting case, which is very recent. As you can see here, Naval Air Facility El Centro, California. The optical images from satellites show there are several tents here, but when we took SAR image, we can see through the tent and identify there are aircrafts below the tent canopy. You can see here the tent is made of some plastic here with some structure, and there are F-35C aircrafts below. And you can see tents without aircrafts, tents with aircrafts. Here is an interesting airport which is of high interest to Indian Air Force, Hotan or Haitian airport, with which is not far away from India-Chinese borders, inside China. Several aircrafts here which are ready to fly whenever they need it. And here is a missile base in Iran, Isfahan, and there are a lot of construction work going on for underground missile facility. You can see here 2 hardened concrete pads for transport, erect and launch pads for nuclear missiles. And these are the underground tunnels below these hills. Well, China-India skirmishes, you are all familiar with this, and we have been monitoring some of those areas. As you can see here, Ladakh region, and the images, I will specifically show 2 examples, Rezangla and Rotag. The Rezangla is the area where Chinese PLAGF and Indian Army were face to face. The distance between them was only 130 meters. You can see here PLAGF tanks. We actually can see some of their barrels. And here are Indian tanks, 3 of them here with their barrels, you can see. And the distance between them is only 130 meters. Here are the Indian Army camps. This is as of 23rd January. And as of 13th February, because it has been agreed to withdraw both sides, you can see here PLAGF tanks are gone and Indian tanks are gone, and still Indian Army camps are still there. And keep on silence, please. And here is Rajangla on 23rd March. All of them have moved out. Here is route of location, which is inside. It's about 98 kilometers from Rajangla inside China. And this is as of 7th February. You can see several tanks and armored vehicles located here in their camp. And this is as of 7th February. As of 14th March, you can see a very large number of tanks and vehicles are moved and which are kept ready for action. And Capella can offer this persistent monitoring program to any of our potential users, and where we can offer several times a day, or daily, or weekly, depending upon their interest of monitoring a target. Capella is very happy to offer to Indian Air Force to partner with them. We will be able to offer large substantial capacity on our satellites with direct tasking by Indian Air Force headquarters and our 7 commands. They can image day or night through the cloud, fog, or smoke anywhere in the world, along with ISRO's RISAT satellites. And the imagery will be transmitted directly. Should I stop there? Hello, can somebody please put on that on mute, please? Okay. Oh my God. I'm not only time constrained, I am also noise constrained now.
So I think we're almost to finish now.
Sure, I am at the end, but the noise is more than my voice. Directly delivered to area headquarters and 7 commands through APIs, shortest latency, and they can distribute to all their air warriors anywhere in the world. Capella is also very happy to offer early adopter partnership to build Atmanirbhar Bharat in the areas of analytics. We are already developing change detection, object identification using AI and ML, and moving target indication. We will be happy to collaborate with important capable organizations. Capella also offers satellite lease or buy. We can offer, if Indian Air Force or Indian government is interested, we can offer leasing of satellites for full capacity worldwide or buying of the satellites. And these are the advanced areas where we are working further. We will be very happy to collaborate with the Indian Air Force and any other organization from India. Thank you very much for giving me this time. And please feel free to send me an email at raw@capellaspace.com. I will be happy to answer and collaborate. Thank you very much, sir. I think I did in less than 10 minutes, right?
You will have to unmute, please.
Can you hear me, sir?
Loud and clear now. It's good.
Right, sir. Thank you. I would like to sum up the session because we're running out of time. I would like to thank the 4 speakers in this panel who have been very forthcoming and have shared the various issues of all domain warfare, from being a systems of systems approach to the importance of humans and the unmanned machines, where the balance has to be struck. And also the issue of data fusion, which is so important in warfare, in all spheres of warfare, be in the air, ground, or on sea. And the important about imagery and interpretation and how that can be used for warfare. I think for all the 4 topics are so relevant and to the present issues at hand. I'd like to thank General Poss, Dr. Felix, Dr. Cummings, and Dr. Rao for an excellent exposition, and a good round of applause for them. And I would also like to tell all the speakers and the audience that being a stage of coronavirus, please stay healthy, stay safe, and stay fit. All the best from my side. Thank you.
We also have the certificate of appreciations on behalf of the chairman of the session, Air Marshal Krishna. The certificates are here. This will be mailed to you. General Poster, thank you very much for being with us today. Dr. Felix, wonderful presentation. We hope to hear more from you. Missy, you've done a great job, and thanks a lot for taking time off and being with us. Fascinating. Dr. Rao, thank you for your support and looking forward to interaction with the Indian Air Force. So with this, we have to close this session as we move to the next one. And it's my pleasant duty to request Mr. S.P. Shukla, our president, to kindly take us through the valedictory session. Thank you.
So much, Mr. Samattar, and welcome once again to everybody. Now we are entering the concluding section of today.
Mr. Kant has not joined yet.
Vivek, has everybody joined in?
No, Mr. Kant is just, his office is online, but he has not joined right now.
So
I think he'll just come in at the appropriate time, so maybe we can continue with this, I guess.
Okay, fair enough. So Mr. Amitabh Kant, Air Marshal Sandeep Singh, Admiral R.K. Dhawan, Mr. Dilip Shenoy, and all the friends from industry, all the serving and retired officers. It is once again my privilege to welcome you all to the valedictory session. As we have heard many speakers today, there is a clear shift towards imbibing AI in warfare. Till recently, this was in the realm of fiction. However, the day is not far when big data, analytics, AI-powered decision support systems, and the automation of various systems powered by AI will be an integral part of military operations. As we discussed earlier, we clearly notice that warfare is increasingly becoming a function of connectivity and is not limited to firepower. From net-enabled warfare to net-centric warfare, now we are reaching a place where AI will play a key role in delivering the right amount of coordinates at the right place at the right time. I will not enumerate further details. Admiral Dhawan will be presenting a summary of today's symposium later. I would also like to welcome Mr. Amitabh Kant, who will be speaking in this session on national AI strategy, and it would be an apt valedictory address for this seminar. We look forward to your vision, sir, for development of a robust AI technology providers framework within the country and promoting the uses of the same across the industry, government, armed forces, and especially powering our air warriors in relation to our theme of today's e-Symposium. May I now invite Air Marshal Sandeep Singh to address the symposium as our guest of honor. Sir, we hope to get your perspective in continuation to the vision shared by Chief of Air Staff during the inaugural session. Thank you, sir. Jai Hind.
Thank you, Mr. Shukla. Can you hear me clearly? And
yes, sir.
And video is also clear?
Absolutely.
Okay, right. Once again, thank you. Chairman Sandesh, Admiral Dhawan, Chairman FICCI, Defense and Aerospace, Mr. Shukla, eminent guests and participants from the Industry Academy and the Armed Forces. Very good evening to all of you. It's indeed a great privilege for me to speak towards the end of such an enlightening and enriching series of talks on artificial intelligence, particularly its role for the air warriors. While we in the Indian Air Force have been planning for some time now on increasing the use of AI for the air warriors, honestly, I've learned a lot through this afternoon's session. I only wish that Air Force headquarters should have had an AI module to help us assimilate the expanse and the complexities of the topic that was so well covered today. And maybe the next. A lot has been said the way future wars would be fought and the role AI will play in them. I will just mention that Air Force, the world over, have led the employment of frontier technologies, and IF has also taken firm steps to support development and employment of these niche technologies, including AI. However, unlike many other technologies whose development was spearheaded by the military, use of AI, especially those related to big data finance, pattern analysis, and many other fields, these have been led by commercial organizations. Some of the experts spoke from those organizations. And defense forces are trying to adopt as well as adapt them for the military use. There are certain challenges in doing so, and we are trying to address them. Many of them, these challenges were articulated by experts during the earlier sessions. As was highlighted by the Chief of Air Staff in his inaugural address, AI has enormous potential for the air warriors in the field of C4ISR or command control communication, intelligence, surveillance, and reconnaissance. The last one we just heard on what the space segment can do for us. The air campaign planning tools, including target-to-weapon matching, the Chief also mentioned, and Air Force has progressed quite well on that. Unmanned systems, especially swarm systems, is a buzzword, how swarming AI will be used. And once again, I think Air Force is all over, and not just Air Force, including Army and Navy, progressing quite vigorously in this field. A man-unmanned teaming has been well covered, and Air Force has also initiated projects with our industry, especially towards this initiative. Lethal autonomous weapons, have been spoken about that whether they will come and how they will come in. Predictive maintenance support tools and many more. While some details of the initiative were given by the CS, and I'll not repeat that, I would only like to reiterate that Air Force has involved government organizations, DRDO and others, academia, DPSUs, and several private companies, including startups, for these AI-related projects. And such projects initiated by us are increasing by the day, I would say. While IF is pushing for its own programs, India has recognized the importance of AI and set up a national mission on AI that is launching various research programs and setting up centers of excellence. You yourself mentioned that, and I think we'll have the privilege of listening to Sri Amitabh Kant, CEO of our Niti Aayog, on India's AI strategy during his valedictory address later on. However, to synergize the efforts of all three services, and that I would say always remains a challenge, and also to integrate that with the national effort, the Ministry of Defense has set up a Defense AI Council under the chairmanship of Raksha Mantri, and Defense AI Project Agency has been formed with an aim to identify projects with tri-service applicability, earmark of budget. In fact, much earlier I've seen in presentation, I think by Microsoft Rep, that we have to spend on this. There's no way we'll be able to bring in AI systems without spending in research, and because it's an evolving field. And also data sharing between agencies. I'm sure other countries would also realize that big data, especially for militaries world over, it becomes very dear to us for sensitive nature. But if we have to make these systems come up, we'll have to forego certain inhibitions in that. And that's where the Ministry of Defense will, I think, with all of us involved there, will evolve these strategies. The MOD-led agencies will also look into the challenges I've mentioned earlier, such as unwillingness of commercial airline companies to partner with military. The trust issue on AI, we are also very, very aware of these issues, as well as ethical concerns, and also resistance within organizations I've already covered to incorporate AI technology and share that data. As was covered well by General David, I think Anurag Rana, in the earlier part I was there, and lately just we heard Dr. Timing also, and many others, that it's instructive to know that the same issue remains critical for other militaries and organizations. I also appreciate and agree with Professor Michael O'Hanlon's remark that at least in the short to medium term, we should not overhype the capabilities or potential benefits of, and he used the word instead of tools or otherwise super advanced algorithms, because AI primarily you could define as an algorithm. And we need to have a well-balanced and operationally achievable goal. That itself is a challenge, that We should not just over-rely on that. But these challenges of cautions notwithstanding, all three defense services in India are fully aware that we are already moving. In fact, you mentioned network-centric operation, and we have started talking already to synergize not just these classical legacy elements, but we have started using the word MDO or multi-domain operations, which adds cyber and cognitive domains as well. And Air Force does believe that to get into MDO, there is no alternative but to start relying AI for assistance during operational planning, at least in the beginning, at strategic and tactical level, and progressively increasing to hand over some of these elements of actual operations to autonomous system, or perhaps non-lethal systems in the beginning, where they can take autonomous decisions. Lethal, as I already covered, everyone also realizes would take a long time, and with a lot of thumping. I think Mary mentioned that perhaps may not happen in the militaries, including pilots. I'm also the pilot, may not let that to happen. And the critical area for us is to define, actually, and that's where headquarters comes in, and I'm giving that perspective, is the AI operational requirements or specifications vis-a-vis the desired outcomes. That where all, why, and what for do we need AI is the starting point, actually. And we have created specially directorates, actually. There are two different this thing at headquarters to handle this aspect. But I confess we need more people. And I dare say we need more young people, actually, who to man these directorates. We want them, and we have already started them to do specific courses, both in India and with other foreign countries. Also, these are the ones who should deeply and freely interact with military and civil agencies to help us make the right and timely decisions at the planning stage itself. And that process is what is happening, I would say, for the last at least 2 years, if not earlier. And we will continue to strengthen this element so that we will interact more and more with industry. As I said, with you all also, for the industry people who are here. We have started to build a pool of such trained specialists, actually, who understands the tactical employment of the weapons and also understands AI and machine learning. And that's why it's a difficult this thing to get this talented pool for us. As the CES had mentioned earlier, to jumpstart our efforts to integrate AI tools, algorithms, or systems, we are also vigorously moving to involve a multitude of agencies and experts. And as was covered by Dr. Paul Klitsch of the US Air Force Research Lab, and we have noted that there has been some collaborative effort which has taken some time to get started, but we are moving towards that. And I acknowledge and appreciate Dr. Ranko's offer to connect with IF for working on AI-enabled preventive maintenance tools. And we actually look forward to such collaborations. I know, well, it is a requirement that countries need to get together, which are friendly in our missions and these things to evolve new capabilities. So to conclude, I would like to say that we are standing at the cusp of the next level of revolution in military affairs. I don't like that word, so I would say military operations, so very more focused. In the coming years, we will witness that the artificial intelligence augmenting the human ability in fighting air battles, more so I would say in planning air battles and air campaigns. That will add efficiency, effectiveness, and agility in air operations. I'm sure the term OODA loop has been used again, and it's important for us in our scenario. So I would sincerely thank FICCI and Sanders in organizing this e-Symposium with such eminent speakers. It has really helped IF get a better insight and better and exciting ideas on how to take forward our projects that would enhance the use of AI for our air warriors in short, medium, and long term. So thank you once again and for this exciting session for us. Thank you again.
Thank you so much, Marshal Sandeep, for those very realistic perspective in any field. I think what you brought is practical realism that what can be done in short term, what can be done in medium term, and what will need to be long-term strategy. That was indeed very useful. That is the only way to work on it. Thank you for those very useful inputs. Now it is my pleasure to invite Admiral Dhawan, AVSM, PVSM, YSM, former Chief of Naval Staff, and now Chairperson of the Society for Aerospace, Maritime and Defense Studies. He has been, as we say, Sutradhar behind organizing this wonderful symposium today. Sir, we request you to give us your takeaway, your summary of today's proceedings. Thank you.
Thank you very much, Mr. S.P. Shukla. Mr. Amitabh Kant, the CEO of Niti Aayog, Air Marshal Singh, the Deputy Chief of the Air Staff, Mr. Dilip Shenoy, the FICCI's Chief Executive Officer, as well as Mr. S.P. Shukla, who is the Chairman of FICCI's Defense and Aerospace Committee, our eminent members of FICCI as well as SAMDAYS, distinguished participants from across the world who have taken part in this unique e-Symposium, ladies and gentlemen. It is indeed a distinct honor for me to accord a very warm welcome to Mr. Amitabh Kant, the dynamic CEO of Niti Aayog, for this valedictory session of this e-Symposium on Artificial Intelligence for Air Warriors. As I mentioned earlier, one of the objectives of SAMDAYS is to assist in innovation in emerging advanced technologies such as artificial intelligence, and also to promote the technological superiority in our armed forces by dynamic interaction between the public and private sector. Another objective of SAMDAYS is Atmanirbharta and Swadeshikaran, that is self-reliance and indigenization in the defense sector. Today, we have had an enriching and a rewarding e-Symposium where we've had the experts from across the world covering different areas, different avenues, and different aspects of the artificial intelligence and their applications in future air wars, how to empower the future air warriors so that they can leverage artificial intelligence to fight and win future wars. I will now request Commodore Sujit Samadar, the Secretary of SAMDAYS, and also our founder member, to very briefly cover the various sessions so that we can bring the chief guest of the valedictory session, Mr. Amitabh Kant, up to date with the proceedings as of now. Over to you, Sujit.
Thank you very much, sir. Mr. Amitabh Kant, my earlier boss and the main inspiration for today's seminar on artificial intelligence, which I had the privilege to work with him when I was in Niti Aayog. And let me begin by saying we had a phenomenal participation of more than 29 people from different parts of the world, from the US, from the UK, from Germany, talking about artificial intelligence. Of course, straight off, our air chief gave us some very clear directions on the way the Indian Air Force was proceeding in imbibing artificial intelligence technologies to its warfighting, to its operational enhancement capabilities, looking at manned, unmanned teaming, and to look at how swarm technologies can be used for a variety of applications, including operational training. Then we also had a variety of speakers, including General Dave Dettula, who is one of the most outstanding people dealing with the subject at the Mitchell Institute at the USA, who's highlighted various aspects of artificial intelligence that will go into warfighting in the future. And he put in a caution that whilst the technology is still maturing, a ready absorption of this technology for situations which can lead to damage and collateral damages will require some considered thinking. In the next session, which was on models, algorithms, and applications, I think a very important point which emerged was how do we build trust in artificial intelligence? A very simple question was brought out that once we started driving a car, we had no trust in that car. But today, you may not know how the internal combustion engine of a car works, but we trust that vehicle to take us from A to B. So we'll see in the future, as artificial intelligence grows and the technology develops to the right level, and there is much more ready application for it, artificial intelligence technologies will become an integral part of all our life. In fact, as Niti Aayog had said in its paper, artificial intelligence will become a public good, which will render the government to deliver better public services for its citizens. I think that was a phenomenal thing that Niti Aayog had brought out then, and I'm still learning from those experiences. Then we also had some very important inputs on what are the building blocks for artificial intelligence. First and foremost was communication, and we had a wonderful presentation from the US on Spectron, a startup company working directly with the Department of Defense, who spoke about free space of optical communications, how to improve latency, how to improve bandwidth in delivering the outcomes that artificial intelligence can do. Then, interestingly, preventive maintenance. And I think this is not just about the Indian Air Force, but it's also about the entire fleet and resources that the country has today in being able to reduce logistic costs by imbibing these technologies so that through preventive maintenance, the fleet of logistic support units, whether they are ships, transport, aircraft, trucks, can be predicted in such a way that the downtime is reduced. There are plenty of applications there which can have a clear osmosis from the defense sector to the civilian sector, and in turn from the civilian sector to the defense sector. Then we had some very interesting presentations on the future of unmanned conflict. We are now seeing increasing applications of the use of pods for trafficking, use of UAVs for cargo transportation. And I remember this was one of the key areas that Niti Aayog had worked on in developing the UAV industrial base in India. So it was very pleasant to hear these technologies being spoken about, which Niti Aayog had spoken about it about 2.5, 3 years ago. We also had some very interesting ideas on how to use air launch drones. And that's a very interesting idea which came up from the US from Dr. Paul. In the final session on all domain warfare, the General Poss who spoke to us about what the advancements that the US Department of Defense was doing in terms of teaming and unteaming of aircrafts. Then we had a fantastic session on sensor fusion. Here again, there are plenty of applications in the civilian sector, where RF, electro-optics, comment, SIGINT, the entire database that exists in various places, including the national digital database that is being created, how all those data can be pulled together to create composite pictures that will help operations deliver to its full potential. We had an excellent session by Missy Cummings. She spoke to us at length about manned-unmanned teaming and the hazards in it. You know what? And it was a brilliant example of what a human saw as a truck was not quite the same thing that machine learned delivered on it. Finally, we had Dr. Rao, who showed us some very graphic pictures of using synthetic aperture radar technology to be able to, in the future, see an aircraft taking off or being on the runway even as it takes off. And that will be an enormous advantage for any combatant force. So there we had a very interesting session, and I now leave it back to Admiral Dhovan to go back to the proceedings. Thank you very much, sir.
Thank you, Sujit, for a very, very comprehensive coverage of the proceedings. Actually, there is so much that has taken place during this e-Symposium, and we really look forward to bringing out a report to cover all the enriching presentations and the recommendations which have been made by our specialists, so that we can send it across to all those who are concerned and related with it. I would also like to take this opportunity to thank the Deputy Chief of Air Staff, Air Marshal Sandeep Singh, for a very invigorating talk where he charted the way ahead as to how the Air Force would be adapting and leveraging artificial intelligence technologies into the future of air operations. And I would also take this opportunity to thank Mr. Dilip Shenoy, the Secretary General of FICCI, for organizing these series of webinars along with the Society for Aerospace, Maritime and Defense Studies, including this e-Symposium on Artificial Intelligence. As you're all aware, artificial intelligence has emerged as a new paradigm, which is slowly but surely going to impact on a wide spectrum of activities as part of our human life. In the future, artificial intelligence is actually the essential technology, and experts have indicated that in a few years, once we have the artificial intelligence fully networked, it will have a bearing on virtually every aspects of governance and administration in the new India of tomorrow. This is what the promise of technology, which our Honorable Prime Minister Shri Narendra Modi articulated in his vision on Digital India. Niti Aayog, with the efforts put in by its very dynamic CEO, Mr. Amitabh Kant, was actually one of the first organizations in India which developed the concept of artificial intelligence for the good of the people as to how to leverage artificial technology to provide services in the fields of education, healthcare, in water resources, and even agriculture for the good of the citizens of this great country. We are therefore very fortunate to have with us Mr. Amitabh Kant, who will be speaking to us on India's national artificial intelligence strategy. Mr. Amitabh Kant has a wide-ranging experience in various fields, and you're all aware of his accomplishments. He has actually had wide-ranging experiences right from the branding of Incredible India to Make in India, Startup India, and now, of course, in artificial intelligence as well. May I now request Mr. Amitabh Kant, the CEO of Niti Aayog, to deliver the valedictory address. Thank you very much.
So you're on mute, sir. Mr. Amitabh Kant, sir, you're on mute. You'll have to unmute yourself. You're on mute. You're still on mute.
We can't hear you, sir.
Sir, you're on mute. Chandan, can you unmute?
Mr. Karthik still can't hear you. I think
Chandan or Vaidya, can you unmute it? Vaidyanathan?
Sir, I tried. It's not happening at my end. IT has to intervene, or it needs to be checked at CEO's end.
Vivek, will you call his office here?
Vivek, is it possible to connect in parallel on the phone call so that while we have a video is there, you can put it on the conference call?
We're just calling up him.
I've just spoken to his, Mr. Amitabh Kant's office. Is getting done in a minute or so.
Okay, very good. So while we wait for the connectivity to be restored, Mr. Khan needs no introduction, as Admiral Dhawan earlier said. We are looking forward to hear him on the national.
Yeah, it's done. Mr. Shukla is done. I think we can hear him.
Look forward to your vision for development of the framework of AI developers, technology developers in the country.
Yeah, Mr. Shukla, I think he is now unmuted. We can request him to speak. Mr. Amitabh Khan, please.
Perfect.
Can you hear me now?
Yes, we can hear you, sir.
Yes, sir, we can hear you now. We can hear you now, sir.
Is it okay now?
Yes, sir.
Okay. So Admiral Dhawan, distinguished guests, Air Marshal Sandeep Singh, Mr. Shukla, Mr. Chinoy, Mr. Sujit Samdar, all the distinguished guests, ladies and gentlemen. I'm truly delighted to address this August gathering. I would like to congratulate both the FICCI team and the Society for Aerospace, Maritime and Defense Studies on the success of the e-Symposium on Artificial Intelligence for our air warriors. Artificial intelligence has been catalyzing the technological landscape in the last few years. Its impact is being universally felt across all sectors. It is a game changer in many, many ways. It has been transforming various sectors, particularly the smart mobility and the defense sector. And it is also transforming how countries govern. Early on, we understood the relevance and importance of artificial intelligence and worked towards the development of a national strategy. Niti Aayog came out with an AI strategy in summer of 2018, and India became one of the first countries to talk about the use of AI to address inclusion and social empowerment challenges. The strategy identified priority areas for the application of AI, such as healthcare, agriculture, education, smart mobility, where the impact on the application of AI technology would be the greatest. I have no doubt in my mind that AI will have a very, very critical impact on defense and on our air, for our air warriors. It will be a very, very crucial and a critical technology having very significant impact. In our view, India today is well positioned to become a global leader in AI. There are several factors which have led to this moment. Firstly, data. The availability of data is central to the development of AI. India now has the cheapest data rates in the world, and with close to 700 million internet users, India is a data-rich country. We now have to move from data-rich to a data-intelligent country. Secondly, public infrastructure. India's digitization efforts through efforts such as Aadhaar, UPI, GST, and other such public digital infrastructure has created an opportunity for artificial intelligence to be leveraged to increase transparency and improve governance outcomes while ensuring that personal data and privacy is safeguarded. Thirdly, diversity. India is a very diverse country, and therefore India's vast geographical and cultural diversity presents unique development challenges in areas such as agriculture, healthcare, education, infrastructure, transportation, defense. These challenges are representative of similar ones faced by other countries. Solving these challenges in India would allow for these solutions to be applied elsewhere. And talent. India has a very large young population that is skilled and eager to adopt AI. As per the 2020 Global AI Vibrancy Rankings by Stanford University Human-Centered Artificial Intelligence, India is ranked globally. India houses the world's third largest startup ecosystem. It has premier institutions such as IITs and triple IITs, a robust digital infrastructure, and millions of newly minted STEM graduates every year. We have the talent, we have the mindset for innovation, and now we have the data ecosystems that are necessary to build artificial intelligence products. Ladies and gentlemen, as I said, India is a diverse country, and therefore there is a huge potential for India. It has the potential to champion the responsible use of artificial intelligence for social good to realize a more inclusive society. This makes India the perfect test bed for not only developing artificial intelligence products for India, but the diversity allows for solutions to be developed for other economies, potentially establishing India as a global technology garage. India has a significant stake in the ongoing AI revolution. In order to make good on the promises, there are a few key challenges which have to be overcome. Firstly, R&D. We need to publish many more documents compared to that of USA and China, and therefore applied research and core research is critical. Secondly, computing infrastructure. India's supercomputing infrastructure has to catch up, getting the right infrastructure in terms of quantity and democratizing access to the said infrastructure is key to unleashing the potential of AI. Thirdly, privacy and data security. The promise of AI represents a wealth of opportunities. There are key privacy, data security, and ethical considerations that have to be accounted for. Responsible management of AI in India is key to leveraging benefits of AI while minimizing the risks. Understanding these key challenges, the National Strategy for Artificial Intelligence highlights interventions that will enable us to become a global leader. Firstly, we have to incentivize both fundamental and applied AI research through the setting up of Center for Research Excellence in Artificial Intelligence, CORE, and International Centers for Transformational Artificial Intelligence, ICTAI. The cores will be established in top-down institutions such as IISc, ISI, IITs, IIITs, etc., which will focus on core AI research in new and evolving areas while maintaining deep multidisciplinary linkages. In parallel, ICTAIs are envisioned to be vehicles of applied research and development and are also expected to be structured as public-private partnership, allowing for the delivery and commissioning of ambitious moonshot projects. Ladies and gentlemen, for India to maximize the effective leveraging of AI tools, we need to cultivate and harness our biggest asset, human capital. And the new education policy 2020 will be a great enabler with its great emphasis on skills. We also need to adopt AI and accelerate across all relevant sectors and value chains. In the NSAI, we have envisaged that this would be done through the creation of robust multi-stakeholder marketplaces such as data marketplace for data for training AI models, the data annotation marketplace for crowdsourcing data annotation requirements, and a deployable model marketplace which will bring together buyers and suppliers of AI solutions. Ladies and gentlemen, finally, the most importantly, all development and deployment of AI must be done in a manner which carefully accounts for considerations pertaining to ethics, privacy, and security. In July 2020, NITI Aayog released a draft document towards responsible AI for all, containing the principles of responsible AI, developed in consultation with leading national and international experts. Ladies and gentlemen, the government has a crucial role to play in positioning India as the tech garage of the world. We had recently held the first Responsible AI for Social Empowerment, which was inaugurated by the Honorable Prime Minister. RAISE was a global virtual summit on artificial intelligence with over 146 countries participating. RAISE brought together the leading global minds in AI and provided great input on the implementation of India's AI strategy, as well as to further enhance India's national AI capability. The government will have to play the role of a catalyst, bringing together the synergies of the private sector with the aim of innovating for India and the world. especially for applications relating to the use of AI in the defense sector, there needs to be more collaboration between the private sector, startups, and academic institutions. Ladies and gentlemen, greater commitment to funding research and development by both the private sector and the public sector will be critical in ensuring that India is able to retain its position in the global landscape. In our endeavor to becoming the #1 destination for AI solutions and products, we'll not only be taking India forward, we'll be taking the world along with us. AI has the potential to take our GDP up by 1.3% per annum till 2035, according to a study by Accenture. And therefore, ladies and gentlemen, we are a data-rich country. We have the talent. We just need to become more and more data intelligent by using AI solutions for finding the solutions for all our challenges. And if we are able to use artificial intelligence to find solutions to India's problem on agriculture, health, nutrition, we will be finding solutions for the next 500 billion people of the world who will be moving from poverty to middle class in the next decade and a half. With these few words, I conclude, and let me once again congratulate both FICCI and the Society for Aerospace, Maritime and Defense Studies for this very, very unique seminar. My personal congratulations to Admiral Dhawan on leading this initiative.
Thank you, Mr. Kant, for that inspiring address. We couldn't have asked for a better valedictory address for this symposium. Thank you once again. I think all of us will remember the key phrase from data rich to data intelligent, and that's very efficient. Thank you. I would now to invite Mr. the Secretary of kindly works.
Thank you, Mr. S.P. Shukla. Mr. Amitabh Kant, CEO, Niti Aayog, Air Marshal Sandeep Singh, Deputy Chief of Air Staff, Indian Air Force, Admiral R.K. Dhawan, former Chief of Naval Staff and Chairperson, Society for Aerospace, Maritime and Defense Studies, Commodore Sujit Samadar, also from SAMDES, Mr. S.P. Shukla, Mr. Sudhakar Gande, my colleagues Vivek and team. It's been an outstanding day. Early in the morning, we had a lot of people join at the crack of dawn from the US and even Europe to actually address us. And we had a fantastic valedictory address by Mr. Amitabh Kant, CEO, Niti Aayog. Thank you, Mr. Kant, for being with us in this evening to deliver the valedictory address. Thank you for highlighting the efforts taken by the government of India and also talking about the role of AI in the Army and Air Force and the role of private sector. Hearing you is always inspirational, and I'm sure we will develop a partnership to take this forward. Air Marshal Sandeep Singh, Deputy Chief of Air Staff, thank you very much for being with us at multiple times during the day. Thank you for elaborating the critical role that AI shall play in strengthening air warfare and also what we could do together. Admiral R.K. Dhawan, former Chief of Naval Staff and Chairperson, Society for Aerospace, Maritime and Defense Studies. You've always been even an inspiration. Even when you were the Chief of Naval Staff, you reached out to private sector to build partnerships to address the needs of the armed forces. You've taken this role forward as Chairperson of SAMDES. Thank you very much for choosing FICCI as a partner. And thank you, Mr. Sujit Samadar, for presenting the summary of today's sessions for our esteemed guests. Our sincere thanks to Mr. S.P. Shukla, the Chairman of the FICCI Defense Committee, and Mr. Sudhakar Gande for actually steering us through the day. Thank all the session chairs and speakers for being with us, especially those who came in from the US and Europe at very difficult times. I thank the Society for Aerospace, Maritime and Defense Studies and Vega MX, our knowledge partners for this initiative, for their immense contribution in sharing the program. Thank you all the delegates for viewing the broadcast of this webinar on the FICCI virtual platform. Also request you to kindly share your feedback on today's e-Symposium. Your feedback will help us to bring even better symposiums in the near future. Thank you once again, all of you, for your time, for your participation, for your ideas and thoughts, and we look forward to taking the ideas and suggestions made during this webinar to fruition. Thank you very much, and with that, we formally end this e-Symposium.
Thank you very much.
Thank you, Mr. Kant. Thank you, well done. Thank you.
Thank you all. Thank you very much.
Thank you, sir. Thank you.
Thank you very much.